Delegates to please be seated. I see a lot of people standing around. Hope your tummies are filled and your brain is still curious to listen to more of AI and pervasive AI and generation AI and conversational AI, right? All around us. Okay, next we have a keynote addressed by Siddharth Relay, Senior Director at AMD, who will be discussing on how to build a transformational future with open and pervasive AI. Siddharth Relay is a Senior Director with the AI group at AMD currently. He's worked at AMD Xilinx for over 22 years and has a wide range of experience with software tools and libraries. His team is responsible for the development of AI solutions for AI engines, ACAP devices, and CPUs. He holds a master's in computer engineering from University of Cincinnati and bachelor's in electronics from Mumbai University. He holds 14 patents and multiple publications with conferences and journals. May I now request Mr. Siddharth Relay for an intriguing session in pervasive AI. ChatGPT in the last 2 days or 1 day. Event management itself I've used. I've created my entire MC script using ChatGPT. 175 billion parameters apparently it has, and I'm learning a lot more coming to this conference, looking at all the various demos, and it's really exciting as an engineer to be here. I think truly fascinating times with the given, the kind of innovations that are going on, software, hardware, and even materials, to be specific. So that is something I believe around the pervasive AI-ness, Sid is going to touch base a little bit, maybe not on materials, but on the applications and use cases. Let's welcome Sid with a big round of applause now that your tummies are full. All right, we need more energy in the afternoon, guys. Thank you.
Thank you, Rama. We had some challenges getting the presentation. Mic not on? Mic not on. It is on. Okay. Thanks, Rama, for the introduction once again. And it's great to be here. We had some technical snags first with the presentation, now with this one. Hopefully AI will make it all better, right? Okay, so let's get on with what I'm going to talk about today is building a transformational future with open and pervasive AI. We have been talking about AI quite a bit, right? So let's just talk about how can we make AI possible and what's needed for that. Good, okay. So the word AI has been used quite a bit. But in spite of that, AI is still in its infancy. It's very early. There are many, many applications that are enabled today, but there are many more that are yet to happen. For a long period of time, we were talking about AI was in terms of images, and video and things like that. But now it's all about generative AI. Generative AI needs a lot more larger models, much higher compute. So as we get into that, we're going to need a lot more of compute as well as software for AI. There are many applications on the screen here. We're not going to go into each one of these, but all of these need to be powered through AI compute. There are, as we saw on the list of applications, right? There are many applications which have to run on the cloud and enterprise side of the world. In cloud and enterprise, we need very high compute, so 1,000 plus of teraflops. The TCO, the total cost of ownership, is one of the key criteria for cloud and enterprise servers. It needs to scale to many nodes. That's one of the key requirements. And the workloads are very diverse in nature. Now that's on the cloud and the compute side. As you can see from the spider chart there, compute, memory, and scale out is the key aspect of what's needed for cloud and enterprise. On edge, it's different, on edge and endpoint. There, it's more about real time. How can the sensors work? How can I process the data on sensors? How can I do it with the whole application put together? Right? That's on the edge and the endpoint, edge and the embedded side. On endpoint, it's even different, right? On endpoint side, we need to look at battery, the small handhelds, things which are very small form factors. So the total applications that need to run on these three areas are very different. Cloud is different, edge embedded is different, and endpoint is different. In order to serve such a diverse requirement, we need a very broad portfolio. Clicker doesn't work. Okay, sorry. We need a broad portfolio which can go from the highest end GPUs, which can run exascale level processing, to the lowest end on the edge and embedded and the endpoint. On the endpoint, we have things where it runs in ADAS or automotive or things like that, right? So we need hardware solutions which can go from one end to the other end. In order to serve this, we have very diverse architectures. We'll talk about a couple of them today. Right? One is at AMD, for example, we have these CDNA architectures which are used for GPUs. And this is for high performance compute. It's for training as well as for inferences. On the other hand, with the acquisition of Xilinx, AMD now has the XDNA architecture, which is a combination of FPGAs and AI engines put together. And we'll talk a little bit more about both of these architectures in the next few slides. The first one is oops, went too far. Sorry. The first one is the MI300X, or the data center GPUs. This is built on top of the CDNA 3 architecture that AMD has, but it is now combined with 192 GB of very high performing HBM3 memory. The combination of these gives you about 5.2 terabytes per second memory bandwidth. What happens with this is now you can run very large language models on single GPUs at a much higher performance numbers. We'll talk a little bit more about that later in the slides as well. But if you, sorry, it keeps moving on its own. If you look at the total number of transistors on this, right, we have about 153 billion transistors on the MI300X. Just about 6 years ago, in the MX6 GPUs, we had about 5.3 billion transistors. So if you can really look at, the technology has changed so much that from 5.3, there's about a 30x increase of number of transistors. And that's sort of what the level of compute is needed for processing of AI. This is about the CDNA architecture. On the other hand, we have XDNA, which is a combination of both AI engines and FPGAs. We'll talk a little bit about AI engines, but what FPGAs and AI engines do is, this is more about data flow architecture. So it's optimized for AI, which is highly scalable, and then you can have it leverages a deep expertise that we have in terms of compiling the algorithms, which can either go to the FPGAs or to the AI engines. Why are AI engines useful for AI architectures, right? Typically, DNNs are made up of layers. You have multiple layers that you run through the CNNs and all the deep networks, right? With AI engines, you can sort of have each of the layers be attached to certain cores. So while the first layer is running on some set of cores, the next layer is running on different set of cores. So now you can have a complete data flow architecture. What this does is, this gives you high performance at a much lower energy. The slide wants to run ahead of me. Sorry. So this, you can get much higher performance, but at a much better energy, and you can customize this based on your workloads. So this is no longer dedicated or fixed, but you can sort of keep having different algorithms run on top of these architectures, right? Okay, I'm just going to stand here. It's just much easier than moving around. So we talked a little bit about hardware. Hardware is hard, but we are making a lot of progress in that area. But software is actually getting even harder. AI is moving at a much faster pace. As a result of that, we need to have very different kind of software on different architectures. This is a general sort of a chart of a software stack, right? Software stack is moving a lot more towards higher abstraction. So at the lowest level, we have compilers and runtime which are dedicated for a particular architecture. For example, at the lowest level, it understands and it has optimized libraries. We have code generation specific to a particular architecture. Then at the next level, we go towards what is called model compilers. These are machine independent, and these are various optimizations for graph or kernels, different IRs that can work on top of it. These model compilers have an interface on both sides. On one side, they have an interface towards frameworks like PyTorch and TensorFlow, JAX and Onyx. On the other hand, they have interfaces towards our compilers and runtimes. More and more people would want to program at the higher level of abstractions, right? They don't want to program at the lowest level of abstractions. And that's where these frameworks are very important. As AI is moving really fast, it's not something that one single individual or one single company can do this. So everybody needs to come together, and that's only possible if we have an open environment. So open ecosystem is extremely important for making progress on AI. Things are moving very fast in terms of there's a revolution with transformers, large language models. We have many different heterogeneous architectures requirements. As a result, we need to have innovations in terms of sparsity, in terms of smaller models, quantization, and all of that. On top of it, we want to make sure that we are developing AI in a more responsible manner. So ethics and trust also play a very critical role as part of this whole process. Put together, open ecosystem is extremely important for helping us make progress in the AI world. One example at AMD, right, what we have, we talked a little bit about all the different compute platforms we have, that's at the bottom. We have architectures going from GPUs all the way down to CPUs. But on top of it, we also have different software stacks. For CPUs, we have ZenDNN. For GPUs, we have ROCm. And then we have the Vitis AI stack for anything to do with AI engines and XDNAs. Each of these have optimized runtime and optimized compilers and tools. And then libraries that go on top of it, and they plug into the overall ecosystem. I talked a lot about open and ecosystem and all that. One of the things that we have done recently is we have engaged quite a bit with PyTorch and Hugging Face. PyTorch, as everybody knows, is one of the leading frameworks. At this point, we have our GPU and ROCm stack completely integrated with PyTorch. So whenever a new version of PyTorch comes up, we have support on it on day one. And that's what we started with PyTorch 2.0. Similarly, we have now also partnered with Hugging Face, where we have about, the Hugging Face has 330,000 models, and many of them are now running on AMD hardware, different kind of hardware, right? And these are getting optimized for GPUs and CPUs and AI engines as well. This is the software stack that I was talking about. This is the GPU software stack. It can run on both data center GPUs as well as on the Radeon GPUs, which are the desktop class of GPUs. What this enables is it enables people to develop on the desktop and then take that same environment into data centers as well. Right? That's sort of the flexibility that they get by programming towards ROCm and using the ROCm stack that's available. Similar to ROCm, we also have another stack which is called the Ryzen AI software stack. This comes with our AI engines and XDNA architecture. We have this running on both Windows and Linux. On Windows, it's with the MCDM driver framework. This already has support for generative AI built into it. It works with Onyx frameworks at this point, and so we can look at it, it's open for all to program as well. I'm going to give a little bit of quick demo of what's running on Ryzen AI. As you can see, there are 3 different applications that are running on this, right? The first one was face recognition, the second one was depth, and the last one is the scene detection. If you notice the demo, it went very quickly. It did not have any visible performance degradation, but what was happening in this demo is each of these was running on dedicated different AI engine arrays, right? There were, each of them, as you can see at the bottom, they are running on individual AI engine tiles. And this is running on a laptop. It doesn't even need anything, it doesn't even have to go to the internet to do something, right? It's everything running locally. This is an image demo, but there's another demo that we have which is running on data center GPUs as well. And this is running a Falcon 40 billion parameter sort of model. And it's sort of doing the, okay, it's a poem on San Francisco, right? This was at one of our events when we had done it. This is a 40 billion model, 40 billion parameter model, but we have models that can run even up to 70 billion parameters. And all of this is running on a single GPU. So you don't need to have many GPUs. A single GPU can run a complex model like this. That's on the GPU side. And on the CPU side, on the Ryzen AI, and this clicker will not. Okay, sorry, this one is not. There was another demo which was supposed to happen on this side of the screen, which is supposed to show a LLM running on the laptop, right? But somehow this doesn't work, so I can't show that to you, right? Oops. Sorry, so the clicker is messing me up a little bit here, right? But as you can see, right, there are applications which are running on data center GPUs, there are applications that are running on laptop, and these are running quite seamlessly with different kind of computers. Okay, sorry, I ran through the presentation extremely fast, and this is actually my last slide here, right? So in conclusion, the AI revolution is here. There are many things that we need to do as part of AI. It's split into multiple levels, right? The first step of this is to make sure that we have the right level of training. So large model training is extremely critical, and that's one of the things that we can support. While training is important, it's also important to make sure that we have a coverage on scalable inference, sustainable inference. And that sustainable is not only about the cost, but it's also about the environment and the overall ecosystem. And finally, while we do a lot of things on hardware, we also need to make sure that software is equally important. And software a software which is more open and something that can scale from GPUs to the Ryzen CPUs, the entire spectrum needs to happen, right? And that's not my last slide. Thank you very much. This clicker really messed me up.
Sorry about the clicker. Sid, may I request you to stay back? Sure. May I request Mr. Vedmal to come and felicitate Sid, really? Vedmal is our IESA chair. Thank you, Sid. It's interesting to see that 40 billion parameters ran on one GPU. Do you know how many GPUs are needed for ChatGPT? Anybody can guess? I was just searching for it. It's some thousands, 10,000 GPUs, that's what it was saying. So that was an interesting number, right? 40 billion, 175 billion parameters, the correlation didn't make sense, but then that's what it is. It's the number of parameters and the complexity that is using. So next we have an interesting panel session. So it's talking about hardware architecture choices for deep neural networks and generative AI. And we have the panel session led by Mr. Sanjay Churiwala, Vice President at AMD. Sanjay Churiwala is a BTech in electronics from IIT Kharagpur. He's been working in the field of EDA and VLSI for more than 3 decades. He holds 3 patents, has co-authored 4 technical books, including one on machine learning. And his books have been widely read, and in fact, I am also one of those who's read his books on FPGA and designing with FPGA. Has written many articles in newspapers, conferences, and journals in India and abroad. His area of knowledge spans mostly front-end design methodologies. I'd like to now request Mrs. Sanjay Ji at AMD, Corporate Vice President, to please come on the stage and welcome the panelists. We have the panel members, and I request the panel members to be ready. Mr. Raju Dikshit, VP, Head of Vision Intelligence, Samsung. Mr. Durga Pedireddy, VP of Product Management and Strategic Partnership, SIMA.ai. Mr. Raghavendra Prakash, Senior Fellow at AMD. Mr. Madhusudan Kandaswamy, Director of AI Software at Qualcomm. With that, I'll let Sanjay Ji take over for the interesting panel session now.
Hello. So is this audible now? Okay, great. Thanks, Rama, for the introduction. Before we start the panel discussion, let's have about a minute to talk about why we chose this topic. Right? So earlier in the morning, Mr. Anshuman Tripathi talked about how the latest fighter jets have so many lines of code, right? And then Sid here talked about some of the software needs, billion parameters and so on. But all this needs something to run on, right? And that is the hardware. So there's a lot of data crunching that happens. In last 11 years, the compute needs for the most complex algorithm of the time, right? That has increased by 300,000 times, okay? And as per OpenAI, the compute needs are now growing exponentially, doubling around 3.5 months, every 3.5 months, right? Imagine that, doubling every 3.5 months. And then so much data processing, so a lot of memory requirement, and obviously data privacy, security, not just of the data, but also of the system itself, right? So in a nutshell, without the right hardware, even the most sophisticated software algorithm cannot do much when it comes to DNA, nano, generative AI. Right? So effectively, these kind of things require the chip architecture that has the right processors, the right memory arrays, robust security, reliable data interconnections, and all this condensed onto a single chip possibly. Okay? And we hope to hear from the panelists today the hardware architectures on the horizon that can support the needs of ChatGPT, generative AI, DNN, etc. Right? And now a few minutes to explain why our panelists are really the right qualified people to talk about this topic, right? So I start with Durga Pedireddy. Durga Pedireddy works at SIMA.ai. He's a results-driven product management leader with business acumen. His extensive experience in compute platform, edge-to-edge cloud AI solutions, embedded technologies. Over past 25 plus years, he has been taking technology products from concept to launch in various vertical markets. It was as simple as the first answering machine from BPL in India, BPL Telecom in India, to the latest cutting-edge purpose-built AI engine from SIMA AI. He is a VP of Product Management and Strategic Partnership. And prior to SIMA AI, he has held various positions at NVIDIA, Analog Devices, Xperi, is that the right way to pronounce? Xperi, Omnivision, and Microchip. Besides his engineering degree, he holds an MBA from Northeastern University in Boston. So that's Mr. Durga Reddy. Okay. Raju Dikshit, he is a Vice President of Visual Intelligence team at Samsung Research, India, Bangalore. He has been working with Samsung for last 13 years, more than 25 years of industry experience working in multiple geographies, and strong record of high performance teams and embedded systems. Currently, he is building and contributing on camera and vision AI technology for Samsung's Galaxy phone. Since my phone is not Samsung Galaxy, I decided to leave it off the stage before coming and sit here, kind of thing. He is involved in building and enabling on-device AI solutions to improve user experience within given hardware constraints. Raju holds a bachelor's degree in electronics and communications and a postgraduate degree in software engineering. Moving on to Madhu. Madhu is from the software background, and we reminded him that he should be talking about the hardware needs rather than the... but we wanted to use Madhu's views as a consumer or customer of the hardware architecture that is required, right? The constraints that we put in. Madhu is from Qualcomm. He leads the artificial intelligence software development group there. He develops the software for optimizing deep learning inference on Snapdragon chipsets for mobile, compute, auto, and IoT use cases. He's currently focusing on optimizing large Gen AI models to run on his devices. He has 20 plus years of industry experience across AI, distributed ML framework, big data processing, etc. And he also works on multi-node CPU, GPU cluster to reduce the training time. Madhu has 20 plus patent granted and many research disclosures under his name. When Rama was announcing mine, I was feeling very tiny, right, in terms of Madhu. Prakash Raghavendra holds a PhD. He's a senior fellow at AMD India. His PhD in computer science from IESA Bangalore. Before AMD, he has worked at HP in the areas of HP UX and MP kernel and compilers. He also comes from academic background. He was a teacher at NIT Surathkal, NIT Karnataka Surathkal. And as a teacher, he was awarded the IBM Faculty Award for Best Research in Academics. With AMD, Prakash has spent 11 plus years, mostly in the area of heterogeneous computing, including optimizing for CPU plus GPU and CPU and AI engine. He has more than 30 publications, around 20 patents to his credit, right? So all this was just to show that these people are actually really authorized to talk about the hardware architecture of origin. Besides their personal credibility, they are working with the who's and who of this semiconductor industry also, right? So let's start with a question directly related to the topic, right? What's your view on the architecture of choice for deep learning accelerators, right? And we can go in this order. We'll ask each of you to at least share your views, right? You may want to check if your microphone is working. You take this one, we'll share this one.
So actually, before I just jump into architecture of choice, last many years when we started working on AI, for me, magic of AI happens through what I call ABCD, right? Algorithms, big data, compute, and the domain. And that's very easy to remember also. So for me, the domain I apply all this is in vision technology and on-device AI, primarily for smartphones. Given the rapid need for hardware accelerators, with vision technology especially, even for smartphones, with DNNs, with transformer, with diffusion recently, there is a need constantly for faster and faster AI accelerators on device. For me, the architecture should support scalability. It should support low memory. That way, I think we are always greedy on the software side. It should support, should not cause any thermal events, especially on the smartphone. Should be fast and have low memory needs. In addition to all of this, what we feel is for user, concurrency matters. The user does multiple things at the same time. User is not doing one and then wait for something else. So AI could be powering these multiple use cases behind the scenes, but for user, they have to run all together. So concurrency of loads is one critical factor. So all of this actually put together, plus the advancement in technology, right? Especially in the precision scaling. I find that to be one of the most critical area, where I think we'll hopefully talk more about that in this talk today. So the way we are using AI, actually, what I would also suggest is if you could go to search Camcyclopedia. So that's a Samsung site where you will see everywhere where we used AI and how we apply AI in smartphone camera. For low light photography, what we call nightography, for taking expert photographs through expert raw, or to transform your pictures and videos. So we have multiple products like Enhance X, Remaster. So you could actually see how AI is really pervasive. I seen that word repeating from almost in the morning. And I think needs are just increasing day after day, actually. So I think it's actually my pleasure to be here today, Sanjay. Thank you.
Thank you. The way I see this whole era of AI is in two folds. Number one is for any successful application, the key is the performance element of it, right? You know, performance and then the latency. That ties into the experience part of it. That is the number one. And then the second one comes in terms of what we call it as total cost of deployment. That means it has to be feature-proof as well. So we saw in today's session from Tripathi ji as well and other delegates also, there is an enormous need of a lot of parameters, and then the applications are evolving. So workloads are enormously changing and are being complex. To address this market and also to focus on the two elements I talked about, there is a need for acceleration. At SEMA, the way we look at this is that acceleration is just not at a one deep learning model level, but at the entire data flow level. That is, if you're talking about, I think one of the delegates today was talking about vision application, where, you know, when something happens, it has to trigger the event and inform an action. It cannot wait for a day or few hours. So for that, I think, you know, we need to look at it from a software point of view, by looking at the data flow and accelerating that so that at the end of the day, there is a great experience. That's the key of it. And to do that, it is just not the compute architecture, but also we also need to look into the data flow. That is the memory copies and how you are actually getting the weights, storing the weights, and processing the data between your L1, L2, and L3 memory. So that's why we do believe that, you know, these new architectures are truly needed for giving a very good AI experience to our customers.
Hello, good afternoon, everyone. Again, thanks the organizers for inviting me for this. My perspective is, of course, I come from AMD. Obviously, I have to talk about GPUs. The GPUs has been sort of NVIDIA's pioneered using GPUs for deep learning. If you remember, in 1998 is the first time when the convolution neural networks came. But actually, it did not make so much noise like ChatGPT has done today till 2012. It was almost like 14, 15 years before we got the AlexNet, which came and made a lot of noise, and then people really, like ChatGPT is making the noise. I mean, 2012 was like one inflection point in AI. The reason was GPUs, right? So those CNNs were known in late 90s. The CPUs or the cluster were not that powerful to train large ImageNet, like, of course, those days it was just convolution neural networks. The capacity or the compute power was not there till the GPUs were sort of introduced in 2006, 2007, and 2012 is the first time when we. So GPUs have been, if deep learning is what it is today. It is one of the reason is compute power because of GPUs and of course CPUs. Now for the inference, because training is one part, 40% is training. The inference is 60% of market, and because finally you need to deploy for inference, CPUs still play a lot of big role. Again, because I'm talking as AMD, because we do CPUs also as well, and we also have, like Sid was talking about, AIs, low power devices, which are extremely efficient in terms of the power performance, right? Power performance, which are used for inference as well. Now, there are other various architectures which have come. Google has tried, Meta has tried, Microsoft has tried, several architectures. Those are all, I would call it as proprietary, because, for example, TPUs, just Google kept it for themselves, and Microsoft also is talking about their hardware, Meta is trying their hardware. It's all sort of proprietary in their cloud. Now, one of the challenges, one of the big reasons why GPUs became popular, though people sort of hate GPUs because of programmability, is because of the lot of push that software has bring in, right? So the ecosystem has to be ready to accept these GPUs. Now, of course, NVIDIA and AMD has done a great job in pushing these devices to become more viable or more acceptable by the programmers, right? So I think these are, we'll talk about a little more in the next round. But I think one of the reasons for the success of the architecture is the ecosystem development. Yeah. Thank you.
Hi. Good afternoon. Okay, so my point of view, the hardware architecture has been constantly evolving to cater the need for the business. So initial days, it was just a CPU where the industry is focusing on increasing the scalability of increasing the clock rate, cache sizes, number of threads and stuff. And like Raghavendra pointed, then there was a need for having a highly parallel processing. There comes this GPU. With GPU kind of did all those scientific applications. Then comes the need for the ML, which kind of took those GPU to the whole next level, which we are all aware of. Then it's kind of has a tremendous contribution with respect to the training optimization. Then there comes the DL era. So when the DL era came, it kind of little bit different from this highly parallel processing. It needed some set of operations which need to be highly optimized, like MATML and convolution stuff. So that is where we needed another set of accelerator, a little bit different than GPU. That is where this whole list of deep learning accelerators come into existence. They really focused on how to optimize your convolution, MATML, and some of the key operators which constitute the majority of the deep learning applications. So that has been in the industry now maybe for 3 to 4 years, different kind of deep learning accelerators there. Now this Gen AI comes into picture where this current deep learning accelerator itself may not make the cut. There is a need for new innovation on the hardware side, which specifically focusing on this Gen AI need, which different from deep learning with respect to the memory requirement, because Gen AI needs a huge memory. Your memory bottleneck will become a lot more heavier than your compute bottleneck. So we need new accelerators which takes care of this memory bottleneck. And then we also need to worry about your power requirement and then compute speed. So we need to, the new accelerators kind of need to be work performance efficient on the int4 and int8, those kind of context models. And software also, given I come from the software background, right? Software also need to evolve how to kind of run our current Gen AI models in a really quantized, compressed memory form without losing the accuracy. So both of this architecture need to evolve, and it has been evolving, and hoping it will kind of continue to evolve in the future.
Hello. Thank you everybody for your views. Among the audience, if anybody has a question that they want to ask, please feel free to come and stand somewhere near Mustaq is seated, right? And then we'll give an opportunity to you to ask the question also, right? We'll probably dig into some of the items that you all mentioned here, right? So Raju, you mentioned about domain knowledge also, right? ABCD, the D was part of domain. Often when we talk about AI, hardware, etc., we talk about cloud and edge kind of thing. Let's talk a bit about something niche, right? The consumer devices where user experience is very, very important, right? So I would request Raju, you and Madhu, you to share your views, whether that provides some specific challenge or constraints for the hardware architecture.
See, in my view, consumer is king, okay? So consumers, our users decide the speed and the shape of how technology evolves. Today, what consumers expect, especially I'm talking mainly from smartphone perspective, they expect instant response. When you do something on the phone, you want some results. Or at least they want meaningful engagement. So phone is engaging you in some way while results are kind of getting ready. So this is a basic consumer need. Now this actually creates a interesting challenge for AI developers, also product managers and designers to define these experiences. So while we have the hardware accelerators, how do we build these use cases, right? How do we build these applications which engage the user, which give user some meaningful benefit? And I think that is one specific aspect of consumer devices which will impact primarily, as I said, on-device AI, specifically when we talk quantization, how do we do precision scaling? That's extremely critical because that saves on memory, that saves on power. For consumer devices, power becomes another very critical factor, which is directly related to thermal. So something which as a software developer, I hate is when chipset starts getting heated up, right? And that happens because we run it too fast, possibly. So how do we do balance between power consumption, speed, and the thermal? That will define the good consumer experience. And all of this actually has an impact, I believe, in how hardware accelerators are defined and designed.
So I think just adding on to what Raju said, right? Like with respect to the consumer devices, the first requirement is, like even the morning Vinesh also pointed out, they wanted to run, the latency is very important. So they wanted to run everything on device because of the personalization, security, and then those latency requirement, and then the cost also matter, right? So that means we need to be able to kind of reduce or provide the same functionality with the simplified, smaller models on our mobile devices. So, and then that model need to be run on a highly power efficient as well as high performant mode, which kind of contradicting goals, right? If you want to be power efficient, you cannot be you can't increase accuracy. So that maintaining that balance with respect, without losing that consumer experience is a big challenge there. And then that is where this hardware accelerator is expected to play a major role to ensure that accuracy is kind of maintained on the smaller or minimized models of the things which will run on the cloud.
Thanks, Madhu. So Prakash mentioned something that I did not like, so I'll grill some more. Okay. So Prakash said that since I am from AMD, I have to talk about GPU. Okay. So just want to remind, since you are from AMD, you can still talk about FPGA. Okay. So those who don't know, I came to AMD through Xilinx. So building on that, right, I'd want to seek, Prakash, your view on programmability versus ASIC-like functions when it comes to hardware acceleration. And just so that Prakash doesn't feel that I put him on the spot, so Durga, your views also on that same topic, right?
Yeah, thanks, Sanjay. So yeah, I agree. I mean, I talked about AIE also, just to just to keep Xilinx folks also happy. But seriously, programmability to me is the number one criteria for any architecture to be successful. Ecosystem development, the architecture may be as good as whatever, right? We have seen the death of MIPS processor, digital alpha processor, several processors which the compute architecture gurus say the architecture is wonderful, they're number one, but they're all dead. Right? So why is it? I mean, x86 is the king, right? I mean, x86 is the whole data center, 99.99 and whatever, I don't know, except for IBM Power. There is no other architecture which runs the crunches Java or the .NETs, etc. today. It's all because of the programmability, the ecosystem development. I'm not saying x86 is the great architecture, but it somehow has succeeded in the server market, right? Similarly, on the GPU side, unless we make this accessible to programmers to have different ways of programming, easier programming, one of the biggest success for GPUs, again, is because of the Python running on GPUs as is. It's wonderful, right? I mean, where is Python? Where is GPUs? Now, how does the compiler generate the code which can run directly on the acceleration mode with the Triton? We can actually run Python on the GPUs. We have other languages directly running on the GPUs. That has been the success, and then it's easy. For example, any data scientist, for example, they may not even care. They may know, but they may not care whether you're running on the CPU or a GPU, right? They may not know what architecture they're running. They have a model, and then they want to sort of run it as fast as possible, that's all, right? Whether you have 100 CUs or this many AI engines, who cares, right? I mean, I want my network model to run, maybe train in few days, right? Not take months together. So the programmability aspect is very important. However, having said that, the other aspect is, it's again a challenge. It's not as easy as I'm saying. If you look at it, to make it more efficient, as you were saying, the ASIC also is important. I mean, we can't just say, okay, because x86 is popular, let us do everything in x86. No, it's not possible. As he was saying, we have to design the hardware to make it ASIC, to make it acceleration. It's very, very important. For example, today LLM succeeded because some of the components of LLM has been accelerated by the hardware. Otherwise, it's impossible. You can't run everything on x86 just because x86 is well known, right? I mean, it will take 10 times or 30 times slower. Now, that's a balance, right? Now the challenge is to keep the libraries or the ecosystem or the runtime using which we can manage. One example is again from the AMD, we have this latest Dragonfly, HP Dragonfly, where we have the first version of AI is running. AMD has done a good job. I mean, again, classic Xilinx has done a good job in showcasing the demo which Sid showed. I don't know whether you captured it. It's an excellent demo. If you look at that, the demo which he was showing, the teams recognizing the face and people, I mean, we have not contributed on the model is known, right? I mean, you may wonder what is new in this. The model is known. What is innovation there is, CPUs are completely idle. If you look at the CPU's utilization is less than 10%, while the AI engines actually showed on this right side, I don't know whether you caught that attention, every column of those AI is dedicated for each of those different windows. That way, I think you got the acceleration. Now, again, that balance is how do we make it AI is more programmable is what the challenge we have. I think we have some steps where AMD is taking, but the big first step, right? I mean, we'll make sure that has to be programmable. So it has to be a balance between the performance per watt, of course, plus the programmability. Otherwise, things will not succeed, right? Thank you.
Thanks.
Yes, I think I fully agree with you on that, because as the AI applications are becoming more and more complex, and there is a lot of uncertainty, or it's not clear for us that the type of models we have today versus the type of models we will get in few months or few years down the line that requires a different compute. Like, for example, right, he talked about the Llama earlier guest, right? Because if you see the way it has evolved from 70 billion parameters to 7 billion parameters in the last, I believe it's 2 years or so. So this is moving very, very rapidly, this particular technology. So that's why we got to provide the programmability so that it is future-proof. And at the same time, we got to strike a balance between having a good ASIC components or functionalities within the chip so that it gives economy of scale. So the challenge here is that how do you strike a balance? Because ASICs are more prone towards a specific application level. But if you take AI, it's a very horizontal level, right? Because it has got multitude of applications. So you got to really figure out where do you draw the line. So for this particular chip, so I'm going to address these key application areas, and then carve the requirement in that particular segment, and then define your architecture by striking a balance between the programmability element and then the ASIC element. So, thank you.
Thanks. So Madhu, you mentioned you touched a little bit about Vinish's speech, right? Vinish's talk earlier. One of the points that he had mentioned was also about power, which we have not necessarily covered in depth here, right? So I wanted to hear views of the panelists on power, specifically say Durga yourself and Madhu, if you have any views on the power, on how do you want to deal with it, the importance of power versus performance, for example.
Yeah, okay. So that is anyway, like in the consumer devices when I talked about, right? Power is a very important factor. So let's, for example, if you take your, the smart watches, right? If you do not have that much power efficient chip, it doesn't even provide the functionality it needs. So it is not an optional stuff anymore. So for some of the devices, make or break. And then if you move to mobile, running LLM is totally driven by whether you will be able to kind of cater the power which needed to run those computes. So power is a very, very important factor on those edge devices. And then when you move to this data center side, right? So when you try to run, let's say, this whole ChatGPT 170 billion model with the FP32, and that consumes tons of power when you try to make a cloud services on top of it. So it kind of, that total TCO becomes very, very important there on the data center side, because power itself becoming a bigger portion of your total spend with respect to the expenses. So we need to have this accelerator very, very efficient in utilizing those power. And now if you come to this Gen AI kind of requirement, right, they kind of take out the power in both the aspects. One is about the compute need, because you need to have a large number of weights, you need to crunch those math multiplication operation on those weights. So the compute need to be a lot more efficient. And second thing is the memory movement, because large number of like a multi-GB of data need to be moved from DRAM to your respective registers to move. And these data transfers are at least 10 times costlier than the Mac compute. So you need to find a way to optimize those data movement as well. Like you do some compression on the source, move it to your accelerator and then decompress it, or move to the ideas like a quantization, make it like a 8-bit or a 4-bit integer. And then good thing is Gen AI is kind of tolerant for this memory consumption, so we have got lucky over there. So we need to use those technologies to kind of reduce the memory movement, the amount of memory movement, and then have some specific accelerator for that individual operations to reduce it. So with the combination of both memory reduction and then this quantized models, we should be able to kind of meet the power requirement. But without meeting the power requirement, I think we cannot make any progress on this AI side. So it's very important.
Thanks, Madhu.
So I'm a big believer in the edge AI space, right? In AI at the edge. So if you need to really give a good experience to your end customer or consumer at the edge, the performance is the key. At the same time, when you're dealing at the edge, power comes into a big play. So how do you strike a balance between the performance and the power, right? So these both go very hand in hand. As Madhu mentioned, one of the key element is that, we need to look at it, the data flow, how the data flow is happening. Because the more and more you're trying to fetch the data, or you are using a lot of memory copies, that will actually suck up your lot of compute. At the same time, it is more power consuming. So that the key for this is to really architect not only just the hardware block, but also architect the system level block, looking at it from the data flow point of view, so that you minimize the memory copies. And at the same time, you also figure out where the workload should run. I think earlier panels were talking about PUs, right? Because in a heterogeneous architecture, you have the vector processing units, you also have the ML processing units, and also your traditional CPUs as well, and other compute engines. So how do you really leverage the compute uniqueness of that particular architecture, whether it is a machine learning accelerator or is it vector processor? And then combining that from a system level point of view, looking at it from a memory flow, that will really yield you not only a good performance, but also at a very good power envelope. That's one of the things we at SEMA has done. I think you might have been aware of there is a Olympics called ML performance at the edge, and SEMA was the number one in being in that space in the performance per watt category. Thank you.
Thanks, Ram. So there was a mention of quantization aspects, right? And I remember till few years back, there used to be all this FP32, then went to FP16, FP8, FP4, finally single bit, all those kind of things happening, right? So I wanted to hear the views of the hardware side of folks, the three hardware folks, on what do you see, where will it end up going, why has it been going that way? Is it only because the hardware guys did not live up to maintaining power? And what about the view on the accuracy loss because of all this shift from FP32 all the way to a single bit? So start with you, Raju, and then we go like this.
This is my favorite topic actually. To realize anything meaningful on smartphones, this is very critical. It all started with FP32, FP16, moved to Int 16, Int 8. Now Int 4 also is working in some cases, not all cases. I wish one day we'll go to binary, right? He talked about 1 bit. So that would be really the key where RAM, ROM, power, performance, everything just goes through the roof. But it has a predictable accuracy loss. But there is amount of research which is happening in this field. Both actually, so there are techniques like quantization-aware training. There are techniques like post-quantization training, which help you in recovering a lot of these losses. And with the knowledge, especially of AI researchers, it's like so much research happening every day. There are now even ways of fine-tuning your AI models, right, which can bring it back possibly to your Int 8, Int 16 level, the accuracy. And in some cases where there are, I think Madhu mentioned about some of the newer networks are also a little bit tolerant in terms of accuracy drops. So whether with various diffusion or transformer techniques, more and more actually possibilities of building such models, especially with mixed precision. So you could do a combination of this and still get the right accuracy and build that use case what you want to build for your user. So it's an exciting time actually, especially with the precision scaling. So this is what I think will drive, especially on the end devices and as well as edge, I believe.
Yes, I'm fully with you on that because it is a mixed precision and it also goes with type of application you want to address and where. Are you trying to address it at the edge? Or if you're trying to address it at the data center level? Or are you trying to address it at the cloud? Because the workloads and then the models we use at different nodes, if you will, if you actually see the whole flow from the cloud to the edge, it's different, right? So that's why there is a lot of innovation happening in the quantization. You talk about any company in the world, everybody talks about only one thing, that is quantization, right? Because we're trying to get to the bit level to give you the accuracy of what we all used to see in FP32 with the 32-bit level, right? So apart from some other things that Sanjay talked about, there is also PF16, eFloat 16. There is also, right? So we cannot, as they say that, we cannot have one size fits all kind of thing. We need to really pick in terms of the application and what is really needed for that application. What are the KPIs needed for that application? And then go about choosing your quantization scheme and your precision levels. That way, we can provide a good experience. One thing we should all make sure that we should not hinder the customer experience because technology is a good thing, but at the same time, if you don't provide a good customer experience, we will kill the technology with our own hands, right? Because we have seen that. Because when I started one of my careers, initial days, we started about video conferencing systems. Video conferencing systems on the ADA platform, we were using 4 or 5 chips to get that. But experience, we all know how it is, right? So that's why it is really important for us to look at as a totality, software and hardware tying together, and application, what is really needed, and choosing the right combination of that, and so that we can provide a very good customer experience. Thank you.
Yeah, so this is a very interesting topic, like as both speakers said, quantization, and then let me take the liberty to add this sparsity also. To me, sparsity and quantization sort of go hand in hand, because if you reduce the number of bits to 0, it becomes sparse. I mean, like, that weight is gone, right? I mean, that the connection is gone, so you can sparse the network. Now, it's very interesting if you look at it. Even our human brain also, as we get old, some of the neurons stops working. But still, the human does, I mean, the old people also can do most of the activities which a young adult do. Though there are some of the, they may not remember some of the things, but it works exactly the same way. Neural networks are somewhat tolerant to the error, right? I mean, even if some part of the model doesn't work, some part of the model completely doesn't work also, or quantized, I mean, reduced work, still it works. I mean, it's amazing. Another interesting thing is, just because int8 works, int8 accuracy is almost like FP32 accuracy, you can't train using int8. Nobody knows why, right? It has to be trained using FP16 or FP32, and then come back to your training. I mean, during inference, we have to quantize. Now, other interesting is, though this quantization started as with the edge computing, so that if you can fit the model into a small memory device, it also has computational aspects, right? I mean, int8 obviously is 4 times faster than FP32, and int4 will be 8 times. Now, the interesting thing is, the AMD CPUs, x86 also quantizes int4. Though we don't have int4 capability, we just quantize it to int4 and pack it into int8, and then use int4 arithmetic to do it. The idea is to sort of, you can reduce the memory bandwidth, right? So it actually plays in multiple ways. Now, another interesting fact is, never in my, I am a software person, never in my life, the hardware SOC architects, right? Like the person who designs the hardware, they never talk to software guys. Guys, what do you want in the next Zen 7, Zen 8? This is the first time in my life they are, in fact, when I send a mail, they don't even respond, right? Now, they are coming and putting a call with me to ask me what would be the data type probably will be in Zen 7, Zen 8. Of course, they're talking about 2026, 2077. GPU guys coming and talking to me, not me alone. I'm not saying I am such a big guy, but I am saying to some of the software, the deep learning architects, saying that, guys, can you tell me whether int4 would be there, or MX9, MX6 will be there? What do you think will be there in 2026? As though I know, right? I mean, who will know that what is there in 2026? But at least they're consulting us to see what data types, because any instructions changing in x86 is very hard. Nobody will agree to even a small change. When I asked for make it cache size bigger or making this instruction, that instruction, the standard answer is no, we will not do it, right? We have to have such a big business case. Now they are, see the impact of deep learning because of the amount of billions of dollars. They are also forced to sort of adapt to this sparsity, and also this block sparsity, right? So block sparsity is another interesting thing. So every block of 4 or 8 matrices should have at least 4 zeros, right? How do we do it? They want us to have, they want us to recommend them what the data type which will be useful for that. So that shows the impact of this sparsity and quantization. Yeah, thank you.
So thanks, Prakash. So all these answers that keep coming in, right? I'm making lots of notes on many more questions that I could potentially ask. Okay, but then there are people seated on the front bench who are reminding me that we are running over also. So we'll probably close with one last question to all 4 of you, right? Please try to be brief, right? But just wanted to hear your views on where do you think hardware is in terms of being able to support the software for AI deployment, right? Do you think hardware is moving ahead of software, hardware is falling behind, hardware is keeping pace? So views from all 4 of you, right? And then we close this one.
I think my opinion would be, everybody can guess, I feel hardware is really far behind. AI research is exploding, actually. The speed at which new networks are coming out, new architectures, and the whole open source community. So architecture proposed for one type of jobs is getting adapted to do 50 other types of tasks across industries, actually. So it is not just even in one domain. Transformers came from one domain to now vision domain. So it's the speed at which things are changing and speed at which consumer expectations are increasing. That's going to, I think, put humongous pressure on hardware architectures. One quick thing which I wanted to also add is we have need for mission critical, real time or online responses through AI. And then there is also need for which can be relaxed offline. Processing can happen. So both these kinds of tasks have to be catered to with different cost, obviously, and different capabilities to be built. So I guess software is right now running much ahead.
Much ahead, okay. Yeah.
I think the way I see it slightly different, because it is very hard for hardware and software to catch up at the same time, because the cycles are different. As somebody said, hardware is very hard and software is very soft, right? So, but if you look at, since the cycle times are different, the investments are much higher, because if you need to make a chip, it costs you $50 to $100 million, right? But it takes few years for you to get the chip out. But if you take the software, it is rapidly changing. So the best way we can address this, as we spoke a few minutes ago, there has to be a good synergy or good cooperation between the software and the hardware teams. The more and more the hardware and the software teams are talking to each other, really talking to each other, right, for the same cause. That's where I think, we can come out with an architecture that will be future-proof for that period of time. So with that, I think, we can strike a good balance between getting the best out of the software from the hardware architecture. As they say, the rubber hits the road, right? It is the software. Somebody said, damn, it is a software that actually gives you the color and shows you what it is, right? But at the same time, for a software to perform well, you should have the best architecture that absorbs all the key operators that the software needs to actually give you the very good experience. So let us we all are one team, and then we will be one team. As long as we are one team, we will do miracles to provide a very good customer experience.
Thanks.
Yeah, I think I've already touched upon it.
Sure, yeah.
Yeah, go ahead.
So I think I kind of align with Raghavendra's previous view. The days in which the hardware guys do the CPU design without talking to the software guys are long gone. With the regular accelerator discussion, right? When you say accelerator, that means these hardwares are defined for the need of the software. So that is already taken care. And then with this new set of AI workload comes in, it is very, very important for the hardware and software to be co-designed. And then the other challenge with that hardware design is the cycle time is more. It's like a 2 or 3 years of cycle. So we need to be very key about the balancing between the flexibility and efficiency. If you go overboard on the efficiency, then the hardware will become unusable, or the industry on the software side will evolve a lot more, then this hardware will become usable. So that is a little bit tricky on the hardware side, but the software do not have that much limitation. They always found some innovative way to kind of patch things up to kind of work with the current hardware, so that way software goes faster. But I'm hoping all the accelerator and then hardware will quickly catch on.
Yeah. Thanks, Madhu, Prakash, Durga, and Raju for your views. My main takeaways is a lot of work that still needs to be done on hardware. There's no single architecture that will fit everything. Multiple applications, multiple domains, and each of these may require their own custom hardware or work, right? What Venkataji said earlier, that all the hardware guys, your jobs are safe. I think it's not just a question of being safe. You guys need to do much more in order to make sure this technology works, right? And with this, thank you all for your time, right? Thank you.
Thank you.
Thank you for the wonderful panel session. My key takeaway is we don't have a hardware architecture yet that will, be agnostic to all the language LLM models, and we'll continue to do more ASICs and FPGA solutions, and we'll be getting more requests from product solution side. May I now request Mr. Sanjay Choriwala, VP at AMD, to felicitate the panelists. Mr. Raju Dikshit. VP Head of Vision Intelligence, Samsung. Mr. Durga Pedireddy, VP of Product Management and Strategic Partnership, SIMA. Mr. Raghavendra Prakash, Senior Fellow at AMD. Mr. Madhusudan Kandaswamy, Director AI Software at Qualcomm. I'd like to now request Mr. Mushtaq Ali. Mushtaq is also our branding and communications manager for IESA, and not only this, and also from the past conferences at VLSI Design Conference. To the next keynote speaker session on serving the billions, the challenges and opportunities in AI by Mr. Jigar Hilani, Solution Architect and Engineer at NVIDIA. Mr. Jigar is the Director of the Enterprise Solutions Architecture and Engineering team at NVIDIA South Asia. He's a versatile professional with close to 2 decades of experience in supercomputing, big data, AI, infrastructure background encompassing operations, business system design, implementation, and process improvement across the challenging environments. Recognized for his outstanding contributions at Wipro previously, he was heading Wipro's HPC and big data practices. He was awarded as the best technical manager by Mr. Azim Premji in 2017. Mr. Jigar is on the steering committee of HIPC conference, where he volunteered for 15 plus years in building the biggest community of high-performance computing professionals. Mr. Jigar graduated with BTech in Computer Science in 2005, and here we have on his keynote addressing the Serving the Billions Challenges and Opportunities in AI. Please welcome Mr. Jigar with a warm round of applause.
Thank you. I thought I'll save some time, so I came on the stage early. We are running short of time in each case.
I am a translator, transforming text into creative discovery. Movement into animation, and direction into action. I am a healer, exploring the building blocks that make us unique, modeling new threats before they happen. And searching for the cures to keep them at bay. I am a visionary, generating new medical miracles. And giving us a new perspective on our sun to keep us safe here on Earth. I am a navigator, discovering a unique moment in a sea of content.
We're announcing the next generation.
And the perfect setting for any story. I am a creator, building 3D experiences from snapshots and adding new levels of reality to our virtual selves. I am a helper, bringing brainstorms to life. Sharing the wisdom of a million programmers. And turning ideas into virtual worlds.
Build a northern forest.
even helped write the script. Breathed life into the words and composed the melody. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Good afternoon, all. I thought I'll start with presentation, but I realized that it's supposed to end with everything that has got discussed from morning till now, right? Generative AI, on whatever you heard, is either there or it is already in the implementation phase, and you will hear out all the announcements that you hear through what people were throwing ideas. I rest assure you. Starting from chip design to images to text to whatnot, and all are in the news, and you will see these breakthroughs in coming months, not even in years. Very proud to say that. And when I was looking at that, and every time I see that video, I always think of it, how does this get applied to Indians? I'm an Indian first, then an NVIDIAN, right? And every time it comes to India, we are very cost sensitive. And thereby, it is very important for us that we first talk about the cost and the inheritancy that we have as a country, as a challenges and the innovation that we can bring in. So I thought of choosing this topic called Serving Billions, that is basically the Indians, and what are the challenges that we have and how can we solve it essentially, right? And what can we learn from it? So I went back to AI first, saying that, hey, can we have AI help us first, thereby then generative AI can help us first, right? So I've themed around the presentation also in that way, and in true fashion, the traditional AI has to first help India, followed by the generative AI, and followed by the implication of those things as well. And you will see the sequence of that in the presentation as well. So firstly, a very thanks to IESA team in inviting NVIDIA and me for this session. And with that, I would like to start very quickly as we are running short of time. So let's first talk about the inheritance problem or the innovation thing that India has it. And we wish to retain this, call our languages, right? We wish to make sure that what we speak as a traditional day-to-day stuff and not go back to English. And I defer to the discussion which was taking place in the morning. Why to search or learn only English? I want to retain my language that I have known. I want to make sure that my children speak the same language, and thereby I retain my heritage stuff as well. And thereby, conversational AI is the first piece that India needs to have it by its own. Not just the matter of fact that I want to retain my heritage, but also I want to ensure that I'm touching billion people plus in my day-to-day transaction, and thereby make it trillions of transactions every day, as how our economy is already touching in digital payments and other areas as well. So is the case when AI has to touch every Indian. The first piece that needs to get solved is the language. So conversational AI, the most important thing. I don't think so I need to rattle the data. It's well known to you guys. We all are IT guys. We use digital things on a day-to-day basis, and thereby we generate a lot of content. And as an Indian, we generate this content in our local language. So it's very important. As it is important, we also need to understand it is complex. And not just complex from a tech perspective, but complex from an Indian context perspective as well. Our environments are typical noisy environments, very well known factor, right? We have multiple accents. I always love this Hindi phrase which is there, right? Kos kos pe pani badle char kos pe vani. The meaning of that is every mile and a half, the water is changing, or the taste of the water changes. Every 6 miles, the tone of the language changes. And it's a fact. I come from Gujarat, and we have over 6 or 8 different type of tones. And what my mother-in-law speaks, at times I don't understand. It is good. It's better, I agree, right? But I have to still understand that at least, so that I can nod my head accordingly, isn't it? So I learned from my wife, what did she say, right? And then accordingly I create my reactions and quickly give those reactions as well. But the fact is, it is the accent and the tone which is important to us as Indians, right? And thereby I can understand India better and serve India in the right fashion, which is very critical. It's our problem, and we are the first one who has to solve it. not the Western country who has to solve it. Although my company comes from Western, GPUs are all built typically or manufactured outside of India. But I'm still saying if the country needs to be served, this needs to be solved first, right? And of course, it has to be real time. Of course, our infrastructure has improved, but while if you see towards it, we were still living in the 2G world, and thereby latency was the issue. Of course, now we have leapfrogged, 5G is all over, and rolling it out as well. So let's take a classy example of how this, noisy environment looks to be. And I took a little bit controversially video, but I still felt it is the right way of representing the noise level that we have it typically in our stuff. So if you can play the video. And I'm choosing Hindi as a language so that largely everybody understands. I know I'm in South India, but still, I'm hoping that Hindi would be understood.
मेरा विपक्ष के सभी सम्मानीय सदस्यों से मेरा आग्रह है।
We have a noise, but it's still capturing the right
बहुत संवेदनशील मुद्दे पर
that the speaker is talking about.
काफी सदस्यों ने,
right?
सत्ताधारी दल के और विपक्ष के दोनों वर्ग के सदस्य ने चर्चा की मांग की है।
So it's hard, but solvable.
सदन में,
and I think we are there.
चर्चा के लिए तैयार।
I think 99% accuracy.
मुझे मालूम नहीं है,
except those full stops and commas and stuff, which then can require a lot of fine tuning that can be done.
मेरा विपक्ष के नेता को
let's take another example. Maybe if you can move the video. I'll run a little quick. I would love to give the chance to other speakers as well with their right time. No, I think it's the same. Yeah, okay, multi-language with the... I'm sorry, I'm not relying on this. I've learned and I have enough data that I know I cannot train my model, so I'm relying on human to help me with my co-pilot. Thank you. Okay, it's the next one. We will move to the next slide. Yeah? Let's see what it has to show us. No, it is still running the same. No, you go to the next slide. You have to press enter. No, we moved multiple. Yeah, this should be the one.
पता अश्लीले गावे लागता ऐसन गायक लोग से भोजपुरी के बहुत नुकसान हो रहल बा ऐसन गीत से तनी बाँची या भोजपुरी के बचाई एगो आईपीएस अफसर बाड़े मृत्युंजय जी वहाँ के भोजपुरी में उपन्यास लिखले बानी गंगा रतन विदेशी तब भोजपुरी में लिखाई पढ़ाई होको दिरहा विदेशिया होको लेकिन चोली लिपस्टिक वाला गाना पर विचार कइल जाओ हमनी के भाषा में बहुत कुछ बा कजरी गाई कंजरी देखत नहीं की 12
Let's keep this language part as a pause here, understanding that it's very important for us, and I'll come to the implication of this when I talk about generative AI getting applied to billions, essentially, right? Very important. So I move to the next chapter, and of course the applicability of language is there at hundreds and thousands of places. I think many government applications today are supporting multiple languages. I don't know how many of you still use train. I know most of you must be traveling by plane, but all train tickets can be now booked into multiple languages. IRCTC has already announced it, right? And I'm assuming that very soon planes will also announce this because the prosperity is growing across and people would like to use their own local language. It's not that they only prefer English. I still prefer Gujarati to be used, not just English alone, right? And you will see this implication on a daily basis. If some of you follow a handler called Bhashini, which is run by Government of India. It's part of the India stack. We have collaborated heavily with them and these demos were in collaboration with them. Every alternate week you see a new announcement by them with one of the government applications which is getting transformed into multiple languages that the application is able to support today, right? Now let's move to the second chapter of the presentation, right? The evolution of generative AI and what it could do. I'm not getting into a detail of it because since morning we are listening to it a lot. But yes, the applicability is not limited just to text. It has grown from magnified level in terms of bio to physics to chemistry to images to videos to whatnot, right? Even coding and so on and so forth. And of course the ecosystem, we just talked about it, how rich the ecosystem has become, and number of evolution that is taking place on an hourly basis. I would not call it anymore a day basis as well. It's hourly basis essentially, right? And those breakthroughs are taking place. Now let's take those learnings and apply that generative AI in an Indian context, saying that, hey, I want to touch billions of them at the cheapest price. So first prima facie that I want to put across is, when you translate the language, if it is originally built using Indic data versus if it is not built using Indic data, what we see as a cost, I'll come to my second last slide of the presentation, but what is important is, because of this, what you are able to give as an experience to the end Indian citizen is very different, and thereby the application tone is completely changing, okay? So this is in collaboration with the demo that we have created, one of the largest telco in the country. We showed this demo in the IMC as well, and this is to touch 7 crore, right, or 70 million, how we call it as, thelawalas who sits across the streets, and making them Google review enabled, with Google Map enabled, and helping with them with the application in the cheapest fashion, in just few rupees or paisas to be more precise. So it is asking, what shop do you run? It says Mithai Wala in Hindi, and then you are asking about the use case that you want to build, or the image that you want to generate for Google review, right? And it gives you options based on what you spoke, right? And then you put your phone number and that image comes to you on your WhatsApp. Use it for Insta, use it for Google review. The translation piece took place in less than 10 paisa, which is in Hindi in this example, and the image generation took place in less than a rupee. Now I can add some margin and cost and other things as well, and give this as an application to 7 crore people in one go, right? And today, I need not to have, being a, let's say, Pani Puri wala, I need not to have a professional to come and click photos or create some nice, videos and so on and so forth. In my own language, I could go, speak, define, tell what I want. If it doesn't have image, because mine could be the unique product that I'm trying to create, I could upload those images. I could then tell the model that, hey, train it tomorrow when you're ready, tell me, I want to create the images or videos around this, and I could get started with it. Am I touching billions? The answer is yes. Am I touching in a simplistic way? The answer is yes. And am I cost affordable? The answer is yes. Now it's not about memory or GPU cost or a CPU cost or enterprise grade. It's about the simplicity. So for India, what you need to do it is solve India first, right? And thereby solve the application that you can apply it for it. Let's take another example. I hope I have it. That's a repetition, if you can move. It's a repetition. You can move to the next one. That's a simple chat, but it has all ChatGPT data that you can think of it in Hindi.
भारत के वर्तमान प्रधानमंत्री नरेंद्र मोदी हैं। वह 2014 मई से प्रधानमंत्री हैं।
जेनसन हुआंग कौन है?
जेनसन हुआंग एनवीडिया के संस्थापक हैं, जो एक बहुराष्ट्रीय निगम है जो गेमिंग, आर्टिफिशियल इंटेलिजेंस और ऑटोमोटिव सहित विभिन्न अनुप्रयोगों के लिए ग्राफिक्स प्रोसेसिंग इकाइयों और अन्य हार्डवेयर को डिजाइन करता है।
जेनसन हुआंग और नरेंद्र मोदी की पिछली मुलाकात का मुख्य परिणाम क्या था?
जेनसन हुआंग और नरेंद्र मोदी के बीच पिछली बैठक का मुख्य परिणाम एनवीडिया
and the example that we have taken is more generic so that we don't be more specific towards one segment on one particular area essentially, right?
Artificial
intelligence. We could talk about our CEO openly and thereby we ask those questions. Now think of the applicability that you can have it on government apps or the enterprise apps which are willing to touch Indians till the last city or the last village, which has feature phone apparently, but a bot is talking in the local language. It's doable at the most affordable price, right?
भारत सरकार ने
It has summarization like how ChatGPT does. It's exactly the same model. We have taken 7 billion model of ChatGPT 3, if I'm not mistaken. All we are doing it is adding a layer of ASR for Hindi, and thereby it is translating it what it needs to be done. Again, in collaboration with Government of India, that this model has been built out and given it to them as well.
भारत के प्रधानमंत्री कौन?
Okay, let's move to the second last slide if I'm not mistaken. Yeah. So here is the classical thing that I was saying that India needs to be solving its own problem first, then of doing anything else as generative AI. And a classical example, right? We talk about tokens and stuff. I'm sorry, the pointer is not working, but if you see Hello World, it's basically 2 tokens for ChatGPT for a model to train, which is hello and the world, right? As I do not have Hindi data or corpus that I have created for Hindi, I'm essentially making it 12 tokens because hello world in English gets translated in following fashion. Time to compute is 6 times more compared to what it is for English. The sole reason is we have not created corpus or tokens in Indianized version, which is our own language. Not doable? The answer is no. It's doable. I think in the morning they announced it that Uber has now data annotation team sitting out of this state. So is the case, we can also create our own annotators. We have the best language people in the country. We have universities and colleges. They can create the corpus and thereby they can create the Hindiized version of tokens called Namaste, and that may become 2 tokens, Nama and Ste, because these are two different words within Hindi. Thereby I need to distinguish them and train the model, and that will be again 2 tokens, and thereby my time to compute is going to be same as hello world. Okay? And of course, it needs to have Indianized version as well. The biasness that we talked about it in the morning, few people took the examples of Asian face versus converting that into the Western world. So is the case when you talk about C dot, it says Colorado Department of Transportation versus when you train it on Indian version of it, it says that the Central Department of Telemetry, which is the R&D division of Government of India for Telecom division, essentially, right? So we have to give this context of the Indianized version and our own data sets that we have it for ourselves as well. And we are unique in most terms and every term in every vertical, trust me. When it comes to healthcare, we are very unique. When it comes to transportation, we are very unique. The road data, road conditions are very unique in the world compared to, and it changes from city to city. I was talking to somebody in the morning, hey, how much time I'll take? And he said, don't worry, whatever Google Maps says exactly is what you're going to take it. I said, no, in Bangalore it doesn't work that way. If Google Maps says something, I have to add at least 30 minutes, over and above that, right? So he said, no, this is Hyderabad, don't worry. So we change. That's because city to city, place to place, the conditions are different in this country. Atmospherically, we are different. Again, not the world has that kind of atmosphere the way we have it. Thereby, our data is extremely unique to us. And we need to solve our data first, then adopt the technology, and we will make miracles. Okay? I think that's all what I had. And the last slide, being an NVIDIAN, I have to present what NVIDIA does. Sorry, don't end it. Please do. Yes. Yeah? So we do everything that you can think of it. We no more call it as a SoC or a chip or a GPU. We call it as a data center. It's no more a single component. Data center itself has become a one component now, right? Starting from GPUs to CPUs to DPUs, how we call it as part of our acquisition, which is Mellanox, switches, which is layered by the systems and the partner ecosystem that we have, and I have many partners sitting over here. We are very thankful to them. Over and above the software stack, and the most important thing, the accelerated libraries. 450 plus libraries, and we add almost 30 to 40 libraries every 6 months. We upgrade over 100 libraries every quarter. That tells the ecosystem richness that we have. And all these libraries represent one or many AI use cases that are getting used. And they are all being containerized to be used by you guys in any form of factor that you have it. Edge, cloud, on-prem. We call them as NGC, ngc.nvidia.com. Supported by the frameworks which are ready to consume for the enterprise-grade application readiness with the security that you might be looking for it, using those frameworks, helping multiple verticals. And that's NVIDIA in one slide if I have to present it. That's all what I had. Thank you so much. It was indeed a pleasure having you here, and we are thankful for IESA for having NVIDIA here. Thank you. I hope I did justice on time.
That was an excellent presentation and a lot of takeaways. So now I request Mr. Durga Pedireddy, VP of Product Management and Strategic Partnership, SIMA, to felicitate Mr. Jigar Helani. Next, moving on, we have another keynote address from Amazon on generative AI, challenges and opportunities, and accelerating generative AI from solutions to production. I'd like to welcome Mr. Anurag Seth, Principal AI ML Advisor, AWS Startups, Amazon. Anurag Seth, a passionate technologist and an executive with a track record of launching innovative products across multiple industries, including semiconductor, hardware, software, and AI-driven solutions. He excels in building and managing offshore R&D centers, optimizing global organizational processes. He's a CTO in residence and partner in a deep tech venture fund. He also served as a CTO in residence and partner at a deep tech venture fund, focusing on AI ML algorithms, tuning based on optical flow, and leveraging Intel's OpenVINO and NVIDIA's DeepStream platform and TensorFlow deep learning platforms. At Amazon AWS, he currently works as a principal AI ML advisor for Indian AI ML startups. Let's welcome Mr. Anurag Seth for leading us through the Amazon's innovations.
Thank you. Mic's working. The mic's working? Can you? Okay. Hi. Good afternoon. Thank you so much. Pleasure being here. And kind of sort of welcome, sort of a coming home sort of a thing. I've been a semiconductor EDS person for the longest time, but yeah, last few years have been spent around AI, ML, generative AI, and the startup ecosystem. Can I take a presentation up? Perfect, perfect. So let me move forward. So I think, thanks for a kind introduction, but oops, yes. So again, my current role at AWS is essentially, as part of the startups team, I work with all generative AI, ML startups across Asia Pacific, Japan, and India. So we just finished an accelerator. And see what's happening. I mean, we invited applications from generative AI startups across India and Korea. We received 400 plus applications from India, generative AI startups. It's such an overwhelming support. See what is happening in this industry, right? We selected about 35, took them through a 6-week of an accelerator. Wonderful set of use cases being handled by them. It's a very diverse cohort which just launched. So what is happening again? Two things. We're at an inflection point. I think you've been hearing about AI ML this morning. Inflection point because of three things: compute capacity increase, the data growth, and model sophistication. And we'll talk a little bit more about it. So again, generative AI is everywhere. I think these are all, you've been sort of bombarded with these sort of use cases and stuff since morning. I'll not speak much about it. But anything you do, any industry you see, across the industry, there are use cases emerging. Right, in terms of, from financial services to healthcare, life sciences to, it's not just about ChatGPT, of course, that sort of propelled the interest last year, right? But everything else, right? And it's the fastest growing trend in AI today, right? I mean, you have the Stable Diffusion accumulated 40K stars on GitHub in the first 90 days. The ChatGPT reached 1 million mark in just 5 days, right? Look at the graph here. Stable Diffusion is right in the steepest path over here compared to any other things you see, from Bitcoin to Ethereum and so on. Look at the growth you've seen in generative AI. And of course, Gartner says that next 10 years, the productivity improvement because of generative AI would add $7 trillion to the world economy. That's humongous. So that's something which is happening to this happening. The use cases are across. Again, I'll just pause here. This is my favorite slide. From a text, look at the amount of things you can do on just about the GPT stuff, right? From summarizations to Q&A to customer support, conversation analytics to intelligent document processing, you name it. Anything you could. There are everyday new cases emerging to manage with text, right? Code generation. We have our Amazon Code Whisperer. You write comments, it generates code for you. Our research suggests 57% productivity improvement of software developers using Amazon Code Whisperer and similar other co-pilots or whatever, right? Code generation, there are other elements of it, right? I mean, you put a code, it'll point vulnerabilities, security vulnerabilities, and tell you how to better code it, right? Images, talking about, Jigar gave an example of, low-cost, India-centric sort of a thing where a neighborhood sort of, store can generate, advertisements using some generative AI capabilities. So again, that's not just a lot of stuff around images can happen. Speech, dubbing, all kinds of things are happening. Video personalization, you'll see some of the examples. 3D gaming, avatar generation, you name it. Drugs, healthcare is huge. The stuff around drug research. How much does it cost to get a single drug to the market? Any guesses? A single drug to the market, including clinical trials. 8 to 10 years, it costs how many dollars? No points, no negatives for guessing wrong. Any guess? 100 million? It's $2.6 billion today. $2.6 billion. Now, a lot of work is spent about, they generate a lot of those molecular structures, and the generation and then sort of eliminate that in terms of toxicity and other stuff to do before they even hit the clinical trials. Generative AI can cut that time by significant margin. Look at the impact this can have, right? Similarly on the, radiology images, the note-taking and everything. So the impact, it is going to have is going to be humongous, right? Synthetic data generation, right? The things around, stuff around product design. We have a cohort company which is actually doing mechanical design. You start, it'll give you, the designs of the, wheel caps, the design of the mechanical parts inside the car. They're able to generate using it, give you options quickly, give you analysis quickly, and being able to move forward on that. So the bottom line is each and every industry, each and every, aspect of what we do is going to get impacted by generative AI. So the more I say, the less it is, but I thought at least give you a view. So let's see how some of the stuff. Can you get the audio, please? So let's see, this is again one.
Thanks for calling Octech Insurance. My name is Alex. Whom do I have the pleasure of speaking with today? Thanks, Alex. My name is Carla, and I'd like to pay my bill. Absolutely.
So see what is happening. See what is happening in the space. It is an agent assist. It's not an end sort of a Q&A. It is an agent assist. Agent is taking the call, and agent is being prompted by generative AI in terms of how to and look at the productivity improvement which can get. Can you please play the video? Can you please play the video? I think it's jump to the next slide. Yeah, thank you. Thank you so much.
Agent Assist automatically generates suggestions to help agents resolve customer calls faster. Thanks for calling Octech Insurance. My name is Alex. Whom do I have the pleasure of speaking with today? Thanks, Alex. My name is Carla, and I'd like to pay my bill. Absolutely, Carla. We can process your payment over the phone. I see that your car insurance balance is $75.34. How much do you want to pay? There's a $50 minimum. I'll pay $50. Great. Would you like to use the card that you have saved on file? If yes, can you please confirm the last 4 digits of your card number? Yes, it's 1, 2, 3, 4. Okay, let me enter that payment for you now. To help answer customer questions, Agent Assist draws on a library of FAQs, trusted knowledge sources, and unstructured documents to generate the best responses for your agents. I've just bought my first home. Do you guys offer home insurance? Congratulations, that must be so exciting. Yes, we offer home insurance policies that provide customized coverage tailored to your specific needs and risks. I'm interested in that. Can you describe it in more detail, please? Sure thing, just 1 second. Agent Assist automatically generates suggestions.
So similarly, another product called Product Ideator.
Say you need to create collateral around a new line of solar-powered bicycles. Just type a couple of keywords for your product, and AWS's generative AI capabilities will generate an image and description based on your input in a matter of seconds. Foundation models running on AWS can transform your text input into a variety of marketing materials, from press releases to internal communications memos to social media ad copy. You can even adapt your content for different audiences by generating new collateral across multiple styles and tones. Do you want to enhance or upscale blurry photos for a blog post? Our generative AI capabilities can enlarge the image and increase the photo quality to fit your publishing specifications.
So you get the idea. Another example. So this is again picking from images. Reading an image uses traditional AI algorithms to understand the images and then create using generative AI to generate descriptions of that. So this is going to read it's using a service called Amazon Recognition to detect what's in the image. So right now it's an image of a form. So here is a insurance claim form which has been filled. So that's an image, it's a PDF. And it picks it up and then describes it. This is using Anthropic V1 model to be able to generate what it saw in the image, to describe the image. And you can ask Q&A around that. Again, pretty much using an LLM here called Anthropic Claude 1. So it's what information does the form gather? It's able to give you a complete explanation about what's going on. So again, look at how generative AI is empowering us. From a video, personalization, text to video. Imagine the video production taken to the next level. Prompt James Bond moonwalk on a beach style animation automatically generates that, right? I was mentoring a company in the Bay Area, which is essentially picking up outstandingly in terms of text to sort of video generation and more 3D generation as well, and from a video to 3D generation. Now imagine what it can do. One of the examples they gave was a NATO song, which had a very complicated sort of like movements. It picks it up, uses the avatar, generates a full 3D image, 3D video, which can be imported into any 3D studio. So look at the impact, or it happens on a video production or entertainment production. Now this is close to home. Can you just play the video, please? How many people have seen this ad last year? Last Diwali. Diwali is near this year. How many people have seen this ad? Raise a show of hands. You heard this before? One. Can you just play the video, please? Just click on the photograph. Click on the photograph. Yeah. Just click on the photograph. Yeah. No, go back. Sorry. Go back. Just click on the photograph. It'll ask you a question. Yeah. Just click here. Do a click. Left click.
Big money to hire famous people, but not the small guys. And they are the ones who are still hurting.
Okay, I think. So this essentially, let me, that's okay. Let's move to the next slide. Can you do it? Or let's move on. No worries. So this was an ad which Cadbury's created last year. And the idea was that Shah Rukh Khan recorded this ad once, right, about Cadbury's. And then every local vendor, a sweet shop or this vendor can actually take that and generate its own personalized ad and using generative AI. Shah Rukh Khan recorded only once. His lip sync, his audio, everything was changed based upon the personal store. So now 10,000 or how many, 1 lakh stores generated this ad. Can you? Sorry about that. I think we can just move forward if you can't do it. Let's just move forward. No worries. Okay. So, but this has been happening, right? All this stuff around generative AI has been happening, right? Let's go a little bit of history. What started of it is basically this paper in 2017 called, Attention is All You Need. So this essentially gave the best, all the transformer architectures today use this paper. All the LLMs use this paper today. The foundation of LLMs is this paper, which allowed, to create a contextual semantic meaning of every word in a sentence. Because every word, when I say I go to a river bank, or I go to a bank to withdraw money, or I can bank on you. The word bank has different connotation in these sentences, right? Based upon the words appearing before and after it. So this attention mechanism, the Attention is All You Need paper, actually allowed you to create a multi-dimensional sort of an association between words appearing before and after in context. And that, and again, now it's similarly, for example, food was great, but the service was terrible. The food has relationships, something strong, some weak, with respect to words appearing before and after it. Now, if I create this into multi-dimensional, that this is on nearness, this is on, sounding similar and stuff like that. Now, that captures the nuanced semantics of every sentence. Now, if I train this on billions and billions of sentences available, I'm able to have a large network which has a large number of parameters to be able to capture that nuanced interpretation. That's the power, that's where the LLMs get powered from, right? But this came in 2017. That I played around with this particular model in 2017 itself, wrote an English language essay assessor automatically using these sort of semantics, right? But it took to what happened in 2022, when ChatGPT suddenly caught the fancy of the world. 5 years, but what happened in 2022? Any guess why did it take 5 years for ChatGPT to suddenly catch fancy? Well, what happened is scale. So you guys are all semiconductor guys living the Moore's law for so long, right? So I believe Moore's law arrived in the world of LLMs or language models or NLP in a big way, maybe with the Venetians. Look at the scale, 15,000x improvement in 5 years on the size of the models. 15,000 times improvement, right? Way ahead of anything Moore's law has ever suggested to us, right? So that's exactly what is happening, and that's been the tipping point, that the moment the size becomes into 300 billion parameters, 200 billion parameters, these models start exhibiting very interesting properties. And we'll talk a little bit more about that. But I just want to highlight, is just keeping the time, interest of time, these are encoder-only models, decoder-only models. Bear with me with the technicalities of it. But let me show you one thing, that these LLMs, the one you have played around a lot, are more like a decoder-only models. They are only trained on next word prediction. So it's autoregressive because you don't need to label the data because corpus is available. You know what's the next word coming in, right? So you say and it gives you what's the probability of next word. Next word appearing name has a 99% probability, 98.8% probability of word being city, and so on and so on. And that's what these are trained on. My name, what's the next word? My name is, what's the next word? And my name is, what's the next word? It's a full stop, and then it's sentence ends. That's the reason anytime you use any of these LLMs as an API, it's called a completion API. Give it a context, which you call prompt, and it's going to only recommend what's the next word, keep generating that. Can you believe it? There's no sentientness over there. The old LLMs, largest of LLMs, are trained on something called next word prediction. That's all they're trained on, right? But they exhibit very interesting behavior. And that's what the wonder of it is. Even the original developers, when ChatGPT of the world came in, were surprised at the sentientness or the intelligence they're trying to exhibit. Others are the sequence-to-sequence models. They have both encoder and decoder. So in that context, they're good for language translations, right? If you have an English word, it'll convert into a semantic interpretation of the sentence and then generate something from that interpretation, which is going to be so good for language translation. So I'll just not go into many details of that, but needless to say, that similarly the stuff around image generation, text to image generation, the stability.ai or the DALIs of the world and so on, they're also built on things like VAEs, variable autoencoders or GANs or whatever. And interestingly, these are also probabilistic models. So essentially what they do is they do not, the typical CNNs like for computer vision would only learn to generate using image and recognition and doing some sort of segmentation around that. But these guys learn to pick up the probability distribution. I give it a set of images. It learns what's the variation, what's the probability distribution, and then randomly, based upon the sentence given, randomly sample that distribution to generate something which is meaningful. So the bottom line here is, similarly on the stability process, using some probability distribution, noise and denoising, but the bottom line is two things. These models are what they call very good few-shot learners. Few-shot means just like human beings do. I teach a kid, this is a remote, I show another remote, and next time I say, it starts recognizing a remote. Similarly, because of the size of the models and the size of data they're trained on, they're able to predict, within few samples. I give few examples. Oh, this sentence, sentiment positive. This sentence, sentiment negative. This sentence, sentiment neutral. And next time ask a sentence, it's able to predict accurately. That's called few-shot learning. 3-shot, 2-shot, 4-shot, or whatever it is, right? They're very good at that. And secondly, they are probabilistic in nature. So they're going to only give probability, whichever way I select the next sentence, generate the word, and so on, right? So idea is that, they will hallucinate. That's the word used. They will be incorrect, absolutely, many times. So that's what happens in these models. So I'll skip this slide of yours. This is just to suggest the compute requirements. Anytime you train or build these models or inference these models, look at the size. This is the typical neural network, sort of a backbone. Even for a 1 billion parameter model, 80 GB of data needed, right? If I show it in a graph, 1 billion parameters is here and 500 billion parameters, which is even more, less than even the current large LLMs are. Look at the size what we need at a 32-bit precision. So that's something we talked about in the earlier conversation. Quantization and based learning and stuff becoming a very, very major norm. How do you quantize it to get the computer requirements low and so on? So key issues, I said, hallucination, lack of current information, lack of access to proprietary. There's a lot of techniques available, the retrieval, augmented generation, RAGs and stuff, which are becoming a part of it. How do you handle that? Coming back to how do you build these models, right? Here is the stack, how you used to build these models. Bottom layer is the silicon layer, which is where the compute is coming from. So that requires cost-effective, low latency, high throughput, high RAM. You saw the RAM requirements early in the last slide, right? Scale. The people like AWS and other competitive, cloud providers, scalable, different models, elastic growth, elastically growing and coming back. Managed, fully managed, integrated, pay-as-you-go, different pricing models and so on. That's a hyperscale compute. Then model ecosystem. A single model doesn't solve the problem. Even LLMs. Different LLMs are needed if you're solving a use case. You may require 3 or 4 different kinds of LLMs. Some are good at summarization, some are good at Q&A and stuff like that. You need multiple models, right? And around that, a lot of ML ops and other fine-tuning options and hosting options and stuff. That's the model ecosystem. And then top of it is the application layer, whether it's APIs or end applications. And again, you can vertically integrate into existing with your applications. That's sort of how an ecosystem looks like when you're taking these models to production. Now, how does AWS come in? At the bottom layer is the silicon. We obviously are one of the biggest partners of NVIDIA. So all the NVIDIA compute is part of our offering. Intel, for that matter, Intel's new ecosystem like Gaudi and other Habana Labs, Gaudi, they're all part of the widest choice of GPUs and accelerated computer available on AWS. More importantly, we have our own silicon, and the Trainium and the custom trained silicon, custom designed silicon. We have a team which is designing Trainium and Inferentia chips, which allow lower latency and lower cost for similar level of inferencing. Hyperscale, I don't need to talk much. It is, we've been there as the leading cloud provider, so entire global infrastructure which is available. The model ecosystem, I'll talk a little bit more. We have 2 aspects. One is fully managed, which is Bedrock, and other pieces where you want to manage yourself. That's SageMaker. We'll talk a little bit more about that. We have 200 plus services at the top layer, AI, ML, including generative AI services on the top. And then we have vertically integrated applications which are using generative AI. The Code Whisperer I just briefly mentioned about code generation. We have, Health Scribe, which is on the healthcare. QuickSight, Gen BI, we'll talk a little bit more about it. And then, of course, you can very easily integrate that into existing infrastructure of IT and applications. Here is the, kind of NVIDIA sort of a variety of compute available. This is our Trainium and Inferentia, I talked about it. 40% better price performance on Inferentia, which is for inferencing, and 50% better cost reduction on Trainium, which is for training. So Hugging Face comment on how Hugging Face feels that we have been able to use Inferentia. Our customers have been able to do that for 8x lower latency. Coming to Bedrock. Now this is where the beauty of it comes in, because we believe in democratization of models, not a single model. So we are under the hood of Bedrock. We have a variety of models to choose from, multiple LLMs, multiple, so example, we have one model called Titan models, which have large LLMs, very good at Q&A, very good at, question answers and so on. Stability is the text to image models. Meta, Llama is also an LLM. Cohere, also an LLM, very good. Anthropic, Claude 2 is also an LLM, and AI21, Jurassic. Jurassic is multilingual. So that they excel at different things. So we can choose which LLMs you want under the hood. Interestingly, we also allow you to fine-tune these models in Bedrock using APIs, and these fine-tuning happens in your own local VPC. So when you send data, the data is protected. Data stays in your VPC. The model which gets trained is also served only for you. It doesn't, none of the data models are used by any other customer or AWS. So very secure from that point of view. Oops. Now importantly, the model itself will not be able to do all the tasks alone, right? You require models to be, as I mentioned, that you have to access your own data, you have to access to your current information, proprietary information, the techniques like RAG, the retrieval augmented generation and so on has to happen. So all that orchestration, all that lookups to databases, you require a lot of other things. And Bedrock comes with something called agents, which allow you to all of that. Do basically not just to select your foundation model, to provide basic instructions what to do, to look at data sources, sift through it, to do the RAG and all that stuff, and then take actions appropriately. So it's all part of the ecosystem. Data is trained in private space. This is another important element that today, these models are getting commoditized. So what is your moat? Typically, your moat, if you're developing an application, would be your data. So data is your differentiator. And AWS obviously has the largest sort of variety of mechanisms to store and fine-tune, manage your data in terms of, clean your data, put the data pipelines and stuff. So bring the model to where data is, rather than take that data model, take that data out and build the model elsewhere, right? So that's where the whole beauty of it is, where people come in, your data is already there, you build in there, right? So let's skip some of these slides. I think, how much time do I have? I'm just sensitive to we're timed already. So we have, wow. So I'll just skip a few slides. I have 2-3 more slides coming in, which is where I'll finish. So other pieces where if you want to not do a managed structure, you want to do your own model, we have something called, flexibility to build your models using SageMaker. So there you completely manage your infrastructure from GPUs. Right? And again, all the models are available, including all the open source models. We also allow the models to be deployed on our Jumpstart, which is a marketplace. So if you're developing models, you can put it on marketplace for other people to use it. That's another important element which comes in. These are 3 interesting applications, which are Code Whisperer I mentioned. Health Scribe is note-taking for physicians in a hospital setting. And the interesting one is, again, I'll talk about the Twig side. So this is how the patient-doctor conversation taking place. They're speaking, the speech is converted into text, and then you sort of clinical notes are automatically generated in a very structured way, ICD-10 compliant or whatever it is called in the healthcare domain. Right, this is a very interesting one. You use BI, right? Business intelligence, like Tableau is a word. So here is a BI tool, which is Amazon's own Quick side. So imagine you'll be able to sort of converse with it, like set the granularity or give this application. So it automatically also gives you generating a story. So write this thing like, create a narrative that can help sales team identify the free trial account, It automatically generates the entire narrative around the story around that, and also backed up with the graphs and so on. So again, this is all happening. Right? So this is the last slide for me, I promise. Just can you play the
Very happy to
video?
be here with the Amazon
Audio.
team and to tell you about a new collaborative project we're doing with AWS and Amazon AI called the Brain Knowledge Platform. One of the biggest challenges with studying the brain is its pure complexity. It's inaccessible to study. At the same time, there's a lot of data about the brain. It's not organized or centralized in a meaningful way. So the Brain Knowledge Platform is really a knowledge base about the brain and a discovery platform. We need this map to know exactly what goes wrong in disease and precisely where to target therapeutics. We've been working with AWS to bring machine learning tools to automate segmentation and other types.
Okay, so that's it from my side. I think.
Very insightful, and it's interesting to see how AI is touching our lives, right? Be it NVIDIA or Amazon use cases. It's really interesting to see the overall space that they're covering today. I'd like to request Mr. Balpreet Singh, Director, Intel Corporation, to felicitate Mr. Anurag Seth, Principal AI ML Advisor, AWS Startups. So, Mr. Balpreet Singh. So moving on, we have a panel discussion now on the generative AI possibilities beyond imagination. It's a stimulating discussion on the possibilities we have, and it's being led by Mr. Balpreet Singh, a seasoned VLSI professional with 24 years of semiconductor industry in the field of FE design and DFT and end-to-end SoC designs. Mr. Balpreet holds a bachelor's from IIT Delhi and a master's from Eindhoven University of Technology. May I now request the panelists to be ready. Vikas Agarwal, Consulting Data Scientist at Oracle. Dr. Manish Gupta, Director, Google India Research. Mr. Bala Prasad Peddagiri, Chief Innovation Officer and Global Head Technology Advisory Services, TCS. Mr. Anand Raman, Partner Director of Products, Azure AI and Bing Relevance Team, Microsoft. And lastly, Siddharth Agarwal, CEO of Innocential.ai. Thank you for the time, and now I hand over to Mr. Balpreet Singh for a panel session.
Yeah. Hello. Hey, thank you very much for the introduction. I'm really glad and humbled to be here, hosting this panel on generative AI, possibilities beyond imagination. This is all along with the stalwarts of the industry, so thanks, panel, for being here. Just want to start by saying that as of today, right, ChatGPT, Bard, Bing AI, DALL-E, other conversational large language models have come to represent what's the best in the industry in generative AI. These tools have captured imagination not only for professionals in AI industry, but also is an active use by the masses. So my kids, for example, they come to me, they show all kind of digital arts, the visual, audio, text. They're showing pictures of us being launched into space, putting us into fight with superheroes, right, and countless others. It keeps them busy, which is very good. But I think what we're trying to figure out today is that beyond the fun part, where is the commercial aspect, where is the business use? And today we saw a lot of examples since morning where we are seeing good productive use of generative AI as well as AI in general, right? So we have today creme de la creme of the industry in this panel. I want to start with Dr. Manish Gupta, just second from next. He's the director of Google Research and co-lead of a technology area in general in Google Research with teams across India, US, and Europe. Manish holds a PhD in computer science from University of Illinois at Urbana-Champaign. Welcome, Manish. Then we have Anand Raman, who is partner director of product management for Azure AI and Bing relevance teams at Microsoft. Anand is passionate about solving large-scale problems, and his team recently delivered integration of OpenAI in ChatGPT, OpenAI ChatGPT in Bing, as well as platform for hosting Bhashini models for Government of India. So thanks, Anand, for being there. Then we have Bala Prasad. He's working at TCS. He has been there for 24 years as a principal consultant and chief innovation officer at Technology, Software, and Services Business Group. Bala is responsible for driving purpose-driven transformation program with technology enablers, research, and innovation functions. Welcome, Bala. Thank you. Then we have Siddharth Agarwal, who's the CEO of InnoEssential AI. He drives InnoEssential AI's strategy and execution. Siddharth is a visionary in automation and enterprise space. His passion for innovation has inspired InnoEssential AI to create groundbreaking technologies and programs that have redefined the automation landscape. Welcome, Siddharth. And finally, we have Vikas. He's senior principal data scientist from Oracle Analytics Cloud. His role is to design and develop and deploy AI applications in ERP, SCM, HCM, CX, MFG, across Fusion and NetSuite customers using generative AI, machine learning, and statistics. Vikas is an electrical engineer turned computer scientist from IIT Delhi, having worked at Caltech, Intel Corporation, and Infosys. So welcome, Vikas.
Thank you.
Really great to have all of you on the panel today. So I want to really start by having a quick intro or understanding of your journey, how you guys got involved into generative AI and AI specifically, and what are your organizations doing. Maybe we'll go from left to right, Vikas, you want to take a lead there?
Sure. So this is Vikas again from Oracle. Something that I never thought was possible, right? Things that we thought would take 20 years to happen, right? When I was a graduate student, I thought, this is not doable. Even 10 years ago, a customer, a CEO of a very large insurance company came to me, can you do this? That I have an insurance agent, I have a customer, they're discussing, and on the side, there is an iPad which listens. And can you just suggest the best policy based on this conversation? And I said, sir, let's come back in 20 years. Now, the interesting thing is, so it's been 13 years since I had that conversation. So maybe in 2-3 years, we'll be able to do this. And when I said 20 years to that guy, I did not believe in those 20 years. I thought maybe it would be longer. So today, what we're able to do for our customers are with these foundational models in vision or in language. Previously, we were not able to depend on these models. But today, I can say, okay, this foundational model will deliver me certain goods. Now, on top of that, I can run my optimization algorithms. I can do additional machine learning to deliver the top-level applications for my customers, whether it's financial, whether it's fraud detection, whether it is customer attrition, any of these, much more ability to give very high quality applications to the customers is available today.
Thank you. Yeah, so I agree with Vikas. I mean, we are in these very, very special times where what looked like science fiction is now possible. So at least the focus for my team has been primarily on taking these powerful technologies and democratize them and make them work for billions of people across the planet, starting with India, for whom often these technologies do not work as well as they do for those of us, right, who are in this room, who are the privileged ones, who understand English and so on. So areas that we have been, at least I'm personally very excited about, is how do we expand, how do we extend some of these foundation models to not just work very well for languages like English, for which they are extremely well designed, but also make them work well for a lot of both Indian languages as well as languages across, many of these low resource languages used across the entire world. Another aspect of democratization that we've been very focused on, which may be of interest to this group, because you're all very close to the hardware, is how do we bring down the cost of serving these models? Because it's well known that generative AI, these foundation models, as they've gone to these very, very large parameter count, now we are talking about hundreds of billions of parameters, and soon we'll be talking about trillions of parameters. How do we bring down the cost of serving those models? Right now we are more in the range of factors of 2x and so on, but we have ideas about how to ultimately, and we are working towards ultimately bringing down the cost of serving these models. We need to do that at least like 10 to 100x, if not more. And finally, I'll highlight that there are still a lot of issues of things like bias. I mean, we'll talk about other issues, but in particular, I mean, if you, let's say, you talked about text-to-image models, right? They are so wonderful, but you give a prompt, right, to say, okay, describe, show me an image of a home. You'll see a lot of homes that very much look like homes in the US, Western countries. You ask for images of weddings. Yes, you'll see a lot of images of Christian weddings in the US or Western countries. You ask for, okay, give me images of Indian weddings. And yes, you will see a lot of now interesting images of Hindu weddings, not really weddings covering other religions, religious communities in India. So there are still a lot of kind of issues of bias and so on, right, that are these large models carry. So again, I'm excited about the work my teams and other colleagues have been doing on how to first understand those biases and then start mitigating them. Thanks, Manish. Thanks for sharing those insights.
Thank you, Balpreet. I think much of the thunder has been stolen by Anurag and Jigar in their talks on the use cases, challenges, and opportunities. But my AI journey within TCS started a decade ago, where our inspiration was to start focusing on building with AI-first approach or machine-first approach. So we have conceptualized the machine-first delivery model, which helped us to start building applications on the narrow-based intents. That's more on the conversations particular to the specific industry. Later, we have created a framework which has an ability to discover the intent, able to carry out the multiple intents and respond to the system. And that's where the general AI philosophy was taken into the context, and we have built a kind of a mediation layer which discovers the intent and responds accordingly. And this has been dog-fooded within our TCS across the different departments of the support functions, and we have seen the results and taken forward in the customer support service areas and also in the contact center areas to see how we can improve the efficiency and the productivity of the customers. That was the first segment of the journey, which really taken us to the narrow AI to the general AI. But later, what happened was the focus was most shifting towards building the products and solutions. And that's where we often see that when we get, as a system integrator company, we get into a lot of consulting engagements, and finding the suitable architects to drive the engagements was very, very tough. So what we decided, why not we design a framework where we can capture the entire consulting mindset of the individual into a system. So we can draw the static inferences and also build the dynamic inference engine. That's where we built Trexus, which is a business advisory and technology advisory solution, a consulting framework which is powered by AI, which normally takes 4 to 8 weeks for one particular consulting. This can be done self-driven without even having the experts within a span of 2 to 3 days. The second product what we built is about the Neuralent. In fact, I have seen AI here in our exhibition booth also. That Neuralent was more powering up the HR and recruitment industry, right from building the job descriptions to the scanning the CVs, finding the best fit, and then scheduling the interviews and conducting the interviews. All these things were built into that entire front-end applications, which will really power up the HR economy. And this has been documented in many customers internally for us, and really shown up how AI can improve your entire product capacity delivery. But later, the third segment is where we have witnessed the entire concept of generative AI. Today, enormous amount of use cases are there. We have witnessed a lot in the last couple of sessions. But as part of the system integration company, what we are trying to do, or my team is trying to do, is focusing on the convergence of what I call it a digital superpowers. My team focuses on multi-edge, multi-cloud, generative AI, metaverse, and 5G. These digital superpowers are really transforming. During this convergence, we are able to develop multiple products and solutions and take our customers' journey into the AI and help them to unlock the new scenarios and create better opportunity to pilot. Today, as I speak, over 120 such engagements are going on where we are helping our customers in this entire journey. I'm proud to say that there is a strong R&D ecosystem which is driven with a lot of passion, really executing the things for the future.
Thank you. Thanks, Balad.
Yeah, thank you for the opportunity. And I'm Anand. I'm with Microsoft. I lead the AI services for India, and I focus on building these foundational models, Azure OpenAI, as well as speech translation and vision models for India here. In addition, I work on the search relevance, Bing search, and bringing the best of the Bing search also into what is known as the semantic search, that is the Azure Cognitive Search. So mostly focusing on problems in India currently. So.
Thank you.
Thanks a lot all the panelists for being here, and thank you, Balpreet.
Closer. I think you have to hold up a little bit.
Yeah, thanks a lot, Balpreet, for giving us the opportunity. My name is Siddharth, and I represent Innocential X Lab for India. And Innocential is a Carnegie Mellon University spin-off. And being a boutique AI practice over the years, we have always focused on solving interesting and difficult problems in AI and across various industry niche and horizontals. And over the years, we have focused a lot on NLP, audio technologies, because we had the opportunity of having those experts who have done pioneering work in this area. Of lately, we are heavily concentrating on how just off the buzz from all the large language models and the humongous amounts of data, we are focusing on how to create some business value and good use cases out of the situations where the data is less. So we focus on tiny ML, and we focus on how even without the internet we can make the devices smarter, like elderly monitoring, or maybe making using transfer learning and federated learning, and we can create solutions for agriculture using the pre-learned models and algorithms, and we can create business cases for law, like creating a talk-to-doc, or maybe ADAS systems in which we can detect the nature of the driver and the behavior of the driver. So that is what my team focuses on. And as many people earlier in the session said, that skilling is a very big area which is required to be taken care of properly to scale the adoption and mass implementation of generative AI. So we also work and set up COEs with governments and industry fraternities like NASSCOM and IESA. And we basically come up with programs in which we use our spatial reverse engineer pedagogy, and instead of teaching, we pick up industry problems and we solve it with the audience and the students, and we try to inject the thought process of critical thinking and design thinking into their thought process, and that is pretty much what we do. So our whole aim is to democratize AI by being a small catalyst and solving key and interesting problems and contributing to our bid by doing a 0 to 1. If I talk about what are the latest problems that we have solved these days, we are a very interesting problem that we would like to discuss today will be that we were using TinyML to detect the seepages and defects on a construction site, and we were using a camera mounted robot to do the site monitoring of the whole inspection site, and because of which we were able to detect which labor was active and which was not, and we were able to create humongous amount of efficiency, and we look forward for the discussion today. Thank you.
Thanks a lot, Siddharth. Really appreciate it. So I think what we heard today in the discussions earlier, right, while we talked about hardware challenges, how do we get hardware optimized to make sure we have accelerated inferences as well as training. We talked about some of the challenges that we have with the models themselves, that they are growing extremely big. There are challenges with respect to hallucination that is happening, right? There is a aspect of responsible AI, ethical AI. So I wanted to take a little bit on your take. What are the key things that need to happen? What are the challenges that we are facing to take us over this hype cycle of generative AI and make it more democratized, as you all are talking about, right? How do you make it take it to the masses? How do you make sure it is for a long run and not a short haul hype that might be talked about, right? Maybe Mahesh, you want to take it on that first, and then we'll...
So one of the things, I guess, which we are seeing is by first starting with this human in the loop approach. So while a lot of these models, yes, they have these problems of hallucination and other things, by pairing them, by again making them not produce the final output, but really become co-pilots to humans, human users who are using these models for things like drafting, creating emails, drafting documents, and so on. So, and even providing an initial starting point, right? Given any question you have, right? Really come up with a detailed kind of a formulation of, again, a potential solution, including things like code. Given a particular problem, these models are becoming very good at even giving you the outline of a code. Of course, you shouldn't rely blindly on the output, which is where the human in the loop is important, that you view the output more as a starting point, which you then as a human user can then further iterate upon, improve, and so on. So that's kind of one method. And then certainly in areas, there are many areas like creativity and so on. As you're creating, let's say, images, you're creating videos, you're creating music, where again, these models are already proving, again, their value in terms of how they are able to generate very, very high quality output and helping kind of with automation or helping with like machine generation of this particular domain of creativity. If you go back 10 years, even most AI experts thought that AI methods would be first used for automating mundane tasks, and creativity will remain this uniquely human endeavor. So you're already beginning to see these models do very well at many of these creative tasks. But again, eventually, if we want these to be used in a kind of in these mission critical applications and so on, and with less supervision by humans, it is important for us to fundamentally tackle some of these basic problems, like one is factuality. So one approach to dealing with factuality is, instead of encoding, because today what happens is the entire world knowledge is encoded in the parameters of these large models. So one approach which many researchers, including my own colleagues at Google, are pursuing is, instead of encoding all that world knowledge in the parameters of these models, can you make these models simply do retrieving? So add an extra layer of indirection. It reminds me of this well-known computer science saving. Every problem in computer science, right, can be solved with one extra level of indirection. So instead of, so get these models to only retrieve some data from an external memory source. You can think of that as a database, as an external memory source in which, let's say, the enterprise is storing its information. And in fact, in actual practice, there is likely to be a combination of such data sources. But by forcing the neural model to not directly give you the information, but only retrieve information, the relevant information from a memory source, can ensure greater adherence to factuality, greater transparency, as well as in that process, you can dramatically reduce the number of parameters that are needed to capture that world knowledge. So that's one example of a technique through which you can hopefully overcome some fundamental barriers that will again come in the way of adoption of these generative AI models in mission critical applications, while also dealing with efficiency and these other issues.
Thanks, Manish. I think it's good to know we're not going to lose our jobs soon, so we just get retrained into new skills. Thank you. Maybe Anand, I will take yours and then I will come back.
Yeah, plus one to Dr. Manish, what you said, right? I think when we think about this, I think I work with lots and lots of customers, right? There are 4 patterns I'm seeing. One is obviously people want the workforce to be productive. So I think, how do you build these co-pilots? We are doing a lot of these things, and how do you build the co-pilots to make them productive, whether it's augmenting code in GitHub or any of those things, right, that you build the co-pilots. The second one is about, process automation. How do you automate the whole document processes or supply chain or any of these processes, right? CRM systems and so on and so forth. The third one we see is customer productivity, like, call centers, traditional Indian call centers, right? How do you make them a lot more productive and so on and so forth. The final one is more creativity, as Dr. Manish said, right? Which is, how do I make these creative things much more better, right? The ads, the digital ads, how do I make it more better and so on and so forth, right? These are the patterns that we are seeing with these large language models.
Thanks. So I think that sort of gives us a view from the hyperscaler organization perspective. I want to now go more from the next level, let's say Oracle and the TCS. They are the users and they're the final application developers for us. So can we hear a little bit more? Maybe Vikas start with you and then come to Bala here.
So I think Dr. Manish mentioned a very important point about factuality. Now at Oracle, our business is all about factuality. Because we have finance customers, pharma customers, you cannot get one number wrong anywhere. So one of the things we are enabling for our customers are very simple things, right? So for example, there's a thing called Select AI. So previously people are used to SQL developer typing in SQL, getting responses back, or any other way of doing that. Now today, all we let them do, thanks to the foundational models, is we let the users say whatever they want. What was my iPhone sales last quarter, right? Now, the key thing here is, now what is going to happen is I do a retrieval augmented generation where the retrieval part is I try to find out what are the tables in my database. I'm oversimplifying, but what are the tables in my database which are relevant to the query, which are columns in that, in those tables that are relevant to the query, bring it all together, create the SQL query, show the result to the user. Now I may again use a foundational model to show the result to the user or transform the result in a form that's easily consumable. They may not want to see a table, they may just want to see a summary. Right? So that's one example of how you can do this. Now, I mean, there are many others we're pursuing, but in the interest of time.
Yeah. Thanks, guys. Bala, you want to add to that, please?
No, the basic challenge is what we see from the system integrator angle is all hyperscalers are providing the capabilities and frameworks. But on the ground, when we try to build the applications, first of all, we need to gain the user trust and acceptance. That is becoming an important challenge. The second important area where we strongly see is model reliability, model fairness, model explainability, model safety. This is also another challenge which we need to really look at. And that's where we are trying to come out with a kind of a framework where you submit your model and the data set. It will able to give you the explainability AI index or trustworthy AI index, which demonstrates and trying to mitigate and build the trust within the user community that model is trustworthy and it is safe enough, fair enough for you to consume the things. The other challenge we strongly see is about a skill gap. Now, this is a huge challenge. People today also feel, when I was trying to speak with some of the associates, they feel that generative AI is very complex. But honestly speaking, it is not complex. You just need to get to the situation on the ground to build the applications, and I believe you'll be able to, the learning curve is very, very easy for you to adapt to that particular thing. Its mindset is very, very critical and important for the associates. That challenge need to be really looked at. Beyond that, data privacy and security, as we are speaking, there is an AI safety summit which happened in London, I believe. So it's all about all government agencies, startups, academicians, researchers. They all need to come together to define the policy framework to mitigate these particular challenges and build the trust. Same thing happened when the cloud came. A lot of trust was not there, but still we are able to build that particular trust to the right certification methods. And now similar thing is happening. We need to get to such kind of a model which can really mitigate these challenges and unlock the belief of the people so that they will be able to embark on this journey.
All right. Thanks. Well, I think that what you're saying basically is that we need to have a framework for authentication, for trust building, and policies around making sure that we have reliable models.
To a level, there is some of the controls which has already been disclosed by the NASCOM also, and some of the European Union controls are also disclosed as part of it, but it need to be standardized.
Sorry. Thanks. Siddharth, you want to add to that?
Yeah, so coming at the last, since all the Mavericks have covered a lot of challenges already, but what we see, a couple of things that we see are still the biggest challenge in the mass adoption of AI across all the industries and across all the countries and community is the bias in the data, because the data that has been labeled all over the years, and AI being a research field, there are certain community and certain languages where data is hyperly more labeled and more annotated, and in other languages and other communities it is not. And all of your LLMs has been trained on certain set of data. And the other communities and other countries, their situations are different, their problems are different, so their scenarios are different. So what we feel is that all the LLMs have a huge bias in them, and there has to be a method to remove or adapt to the bias if you have to serve the entire humanity through the LLMs. That is a very big problem that we see here. And coming to the generative AI, the biggest problem we see in generative AI is, since we are generating image, video, text, and we are generating everything. So there's a humongous amount of content that is getting generated. Some part of it is good, some part of it is fake, and some part of it is totally, not required. And all the LLMs and the chat GPTs train themselves from the data on the internet, which is getting created by the generative AI. So we are getting into a loop. So there has to be a regulation on what kind of content has to be created and what kinds of content needs to be fed to the internet on which the LLM has to be trained. Those are two very niche challenges that I personally feel have been royally ignored because other issues are more prominent and it has to be addressed. But these two problems, if taken well, this great technology can do wonders to our society, moving forward in the coming years and decades.
Thanks, Dad. So given we are running out of time, I just want to close with one question that is more to do with the Indian ecosystem. How are we applying generative AI? How are we taking it to the masses? How are we making sure that it's really applicable and we understand the context and deploy it and make it commercially viable as well? Right? So maybe, Bala, you want to start for that?
From the ecosystem standpoint, I believe there are multiple stakeholders coming in. The first one I want to talk about are researchers and academicians who are really placing their role in the generative AI to experiment and build that understanding and knowledge what is good and what is not good. And feasibility is one of the area which researchers will be able to demonstrate very, very powerfully. The second important space is about startups and entrepreneurship area. These people are coming out with a very, very innovative use cases, leveraging all the generative AI concepts. And I've seen some of the cool solutions as part of the exhibition booth, which truly demonstrated some of the new things which were not understood earlier, but with the power of generative AI, they're able to unlock it. The other area is we also strongly see the government of Telangana started focusing on this space. In fact, few years back, they told it's an AI year, and they started focusing and bringing out a AI-focused ecosystem within the government of Telangana. That indicates the power of this expansion of this ecosystem spreading not only to the corporates, but also focusing government, getting the government support. So government, researchers, academicians, startups, entrepreneurship community, and the policymakers can make a big formation of this ecosystem to solve and bring everyone on board onto this particular journey of generative AI and make a big difference to the community. And this is strong, and getting them together can make a big difference.
Thanks for that. Anand, you want to take it next?
Yeah, plus one to what he said, I think one thing I'm super encouraged by the Indian ecosystem is the mind we have is unbelievable, right? The fact that Dr. Manish and I have come back and we are contributing to India with the hyperscalers is the biggest reasons, right? When you look at what is happening with the India stack, what is happening with the Indian government Bhashini models, and we are far ahead of the world in terms of digital technology, right? We are digital technologically rich. Maybe infrastructure-wise, maybe we are struggling, but I think this is a great moment for all of us and a very proud moment. And this is something that I'm happy to be a part of this panel to contribute to India.
One thing I'll just add is it's also good to look at all of these aspects in terms of as consumers and as producers. So as consumers, again, there's absolutely no doubt. Both kind of are consumers in India as users. We are actually ahead of even countries like the US in terms of adoption and usage, right, of these generative AI technologies. But where I think we need to kind of up our game is as producers of technology. And as producers of technology, again, there are elements where as startups, as researchers, including academia, right, as you mentioned, how do we start to work on some of these gaps that we have seen, right, in these foundation models, for instance, in terms of better support for Indian languages, in terms of all these fairness issues and efficiency and all of these other issues, that I think it is important for us to also become producers and contributors of foundational technologies. And plus one to what Anand said, India has actually, in many aspects of technology, digital technology, India is actually a world leader. When it comes to mobile payments, when it comes to online, trying to democratize online commerce. The kind of protocols, beacon protocol and so on, right, that people in India are developing is actually a great model for the rest of the world. So I think we need to kind of take advantage of some of our leadership in these digital public goods infrastructure and these adoption of these digital technologies, and likewise contribute to even generative AI technologies in a similar manner of leadership.
Thanks, Manish. I think what we're trying to say is also that we are remapping solutions to Indian context. Can we do identify grounds up solutions also, right? So I think that's a valid point. Because Siddharth, just closing remarks on that.
I think the focus on India is critical. Manish mentioned, Jigar previously mentioned as well. There's a lot of development space available here, and we have a lot of talent which is available, ready to jump on that opportunity.
Absolutely.
So that opportunity definitely exists.
Thanks. So that
absolutely. So what I feel is in the last 2 to 3 decades, whatever technology or area India has taken on the heads up. They have, just excelled out of the box into it. It all started from IT, then e-commerce, then payments. And now, when I see the generative AI ecosystem in India evolving and the governments and the, all the industry fraternity and all the startups coming up with such great amount of use cases, right from healthcare. If you see, Google has developed the latest technology in which they can, do the retina scan, and they have developed it for some remote villages in India to, take healthcare to the last mile, and, the drones helping the crops to detect the defects in the crops. So all this bleeding edge technology getting developed only for India, rather than in any other country in the world, is a big statement for our country. And as all of the panelists have said, that we are a country which is erupting of talent thanks to the percentage of the youth we have. And now, all of them are getting skilled in this technology. And we are sitting in a city like Hyderabad and Bangalore, where hyper skilling is also happening. Across all domains in AI, and the amount of zest I see everywhere in all the newspapers and all the news channels, they are having this AI avatars. So AI is all around us in India, and I think India is going to develop. If you'll see the CB Insight AI 100 map, I see India contributing a lot of startups, a lot of good solutions into it in the coming decade.
Thanks a lot. Thanks. So I can obviously sit the whole day, keep talking about this topic, and really has been a fun discussion. Thanks a lot for all your insights, and really appreciate taking your time out for being here. Thank you. We'll close the panel on this.
Most welcome, sir.
Thank you.
Thanks a lot, everyone. Yeah.
Thanks, Balpreet, having us.
Thank you, Balpreet, and thank you to all the panelists. May I now request the volunteers to be ready with the plaques to felicitate Mr. Manish Gupta. Yeah. Will be next. Next, Mr. Bala Pedagiri. We'll be felicitating next Mr. Anand Raman. We'll be felicitating next Mr. Vikas Agarwal. And Mr. Siddharth Agarwal. I'd like to request Mr. Sid Relay to felicitate Mr. Balpreet Singh, the moderator for the panel. Served outside coffee, you can go have your tea. We are not giving a broad tea break per se. You can continue to have your coffee, but please come back in 5 minutes. We'll continue our sessions. At Google India Research to give us an insight on inclusive AI for India and beyond. Dr. Manish Gupta is the director of Google Research India and a co-lead of technology area in Google Research with teams across India, US, and Europe. Manish holds a PhD in computer science from University of Illinois at Urbana-Champaign. He's a fellow of the ACM India National Academy for Engineering and a recipient of Distinguished Alumnus Award from IIT Delhi. Now, I'd like to hand over to Mr. Manish Gupta to lead us through the inclusive AI and for India and beyond.
Okay, thank you. Can I have my slides? So again, continuing on from some of the remarks I made at the panel, I'll talk primarily about our efforts at Google Research India in helping democratize, bringing the benefits of these technologies like generative AI to billions of new people, starting with billions of, over a billion people right here in India. So while these slides are coming up, I'll talk primarily about our work in three broad areas. I'll talk initially about our work on languages, because again, a lot of these models have been developed with English as the primary language in which has provided a lot of the data. Of course, there is coverage of, in many of these models, for over 100 languages, but English overwhelmingly dominates. And therefore, there is that very clear, in some sense, difference, right, in the capabilities of these models for English versus other languages. I'll then also talk about our work in areas like agriculture, which have been relatively less touched by technology, and highlight a few opportunities where, again, you can achieve transformative impact through application of technologies like AI to that field. And finally, the last topic on democratizing is on efficiency, because it is well known that many of these large language models, they cost over a factor of 1000x, and sometimes even more. And the trends are, the gap is, as we continue to really build larger and larger models, the gap is in fact growing further. So ultimately, if you want to serve the entire user base of India at that kind of scale and with the kind of price points that we expect, right, for many of our services, we would really need to dramatically bring down the cost of serving these models. So I'll talk about some of our work on that. So let's start with looking at information. How do we use that fairly large percentage of our population is now becoming, now have access to the internet. But if you look at the information that is available today easily on the internet, right, through things like Google search, through ChatGPT and so on, there's a big disparity between the quality of information that you get when you ask your question in English versus in other languages. And we see that 90% of the new internet users would really prefer to consume content, information in their local language rather than English, and only about 10% of people in India are what you might consider fluent English speakers. So how do we serve, right, those other 90% of the users? So before we even talk about languages other than English, we have to recognize that even the English that we speak in India is a superset of what Britishers or Americans might call English. So what we see, for instance, even when we see query logs in Google, we might see a query like, so in fact, we took inspiration for this work by looking at various signs, including this appetizer menu of a restaurant. And the first instinct might be to say, hey, why can't these people spell these words properly? Why is pineapple spelled this way? Why is appetizer spelled that way? So while you could take that attitude and say, oh, those guys need to learn proper English and spell these things correctly, we recognize that actually these ways of spelling did make a lot of phonetic sense. Because if you imagine this word pineapple raita in Hindi and now try to transcribe it from this Hindi word pineapple into English, this is a very reasonable way of spelling pineapple. And likewise, even the word appetizer, if you recognize that the Z sound is missing in Hindi and the closest sound is J, then this is not a unreasonable way of spelling the word appetizer. So all these editing tools that would do spell correction, they would miserably fail at these kinds of variants of spelling, because these are, in terms of edit distance, very far away from the original words, but acoustically, they're very close to the original word. So that led to this effort, project in our lab called Indophoneme, where we applied AI ML techniques to model different ways in which a user might spell. And then we correlated that with things like actual query logs. So we found that, yes, I mean, when somebody is looking for boy's shoes, we shouldn't say, oh, we don't understand this query. We should understand the intent that this person is looking for boy's shoes and then serve them the appropriate results. So I won't bore you through all the math, but there was a lot of heavy mathematics that went into, again, coming up with all these phonetic variations. For instance, now, a lot of users, right, of Amazon, there are so many different ways in which the word Amazon could be spelled. If you just imagine the word Amazon being pronounced by users of different languages, right? And so we automatically come up with all these variants. And of course, there are variants. We know about Tamil speakers, right? Because ka, kha, ga, gha are all represented by the same letter. So there could be sometimes those variants. I don't want to pick on, I mean, I myself am a Hindi speaker. We Hindi speaker often would change the z sound to a j sound, and likewise, a Bengali speaker, right, might change the p sound to a b sound. So how do we automatically model all of those variants? So in fact, this methodology was used then in the Google search spell correction that now works in India, and as a result, a lot of these queries, right, that I showed would be correctly recognized by the Google search engine. Then, of course, these large models, they have been built using methodologies like things like fill in the blanks exercise, right, that we all learned when we were in school, where the teacher would mask out some words, right, and ask us to fill in the blanks. And in that process, they were testing our understanding of the language as well as ability to reason about things from the context. So likewise, as these language models are trained to predict those missing words, in that process, they end up not just mastering the nuances of the language, they end up also with kind of this knowledge about world, which gets applied for various use cases. So one of the things we first try to make sure is that we make those models multilingual, and at the time of pre-training, not just feed English data, but data from a lot of different languages, so that they're able to work well on various tasks like named entity recognition, part of speech tagging, question answering, on sentiment analysis, that they can handle not just English text, but a lot of other languages, started with Indian languages. So our team had built this model called Mural about 3 years ago, which at that time provided the largest coverage of Indian languages, and we made that freely available on Hugging Face and on TensorFlow Hub, and we saw very significant improvements in the accuracy for various kinds of tasks. We also incorporated that into the Assistant product from Google, and now when a person asks Assistant, right, to set an alarm with all of these kinds of variants, whereas in Marathi, it is basically like telling this Assistant, wake me up at 4 in the morning, set an alarm for sure, don't forget. So the user is using pretty much their natural language style, and it is the job of this semantic parser to essentially understand the intent from this query and generate this call to this API, create alarm, and set the appropriate date and time properly, right, from this query. So we were able to significantly improve the accuracy of the assistant in all of these tasks for all of the 8 Indian languages. And now there's a single model that serves all of these Indian languages. So I challenge the team to support not just those 16 Indian languages plus English, but all 22 scheduled languages of India. And I'm very proud to say that my team did not listen to me. The person who leads our languages team, he said, no, I'm going to go beyond what you are thinking about. So he did this analysis and he said, look, there are 60 languages in India which are spoken by at least 1 million people, and there are 125 languages that have over 1 lakh speakers. And what we might call Hindi, there are so many variants of Hindi. The way it is spoken in Haryana versus Bihar versus Uttar Pradesh and so on is so different. So my lead researcher said, no, I want to, if there's a language that's spoken by at least 1 lakh speakers, I want my model to understand that language. So that led to this project called Morni, where we are trying to build a single model that will understand all of these 100 plus Indian languages. And of course, as earlier Jigar was talking about in his talk, there's this saying, "Kos kos pe badle pani, char kos par vani." We recognize that the way we speak, even a language like Hindi, changes so much as you go from one region to another. So instead of just this language, we wanted to capture all of the variation of how we speak different languages across the different parts of India. It led to this project called Vani, which is being pursued jointly with Indian Institute of Science. We've completed phase 1 already. Over 3 phases, our plan is to collect speech data from each and every one of the 773 districts in India, so that we cover the full diversity of dialects, various accents, and so on in India. And all of this data is being contributed back to an open data set that we are making freely available under the Government of India's Bhashini program, and we are making it freely available to anybody, to academia, to startups, to our own competitors, Microsoft, Amazon. Yes, you are all welcome to make use of this data and build better models to support Indian languages. We've already released from the first phase of 80 plus districts, roughly 15,000 hours of speech data we've already made available. And now what we have been doing is we've been building these models that will marry the power of these large models like Palm and Palm 2 that have been built at Google with the better understanding of Indian languages, so that you can get the best of both worlds. The very powerful reasoning capabilities of these large models and the much better understanding of Indian languages that comes from our exercise. So we've been building those variants. Let me just briefly talk about areas like agriculture that have not been as broadly touched, where what we have been doing, so I wouldn't have time to show you this demo, but we have built the first such model that now, you're all familiar with Google Earth Engine, and so think of it like a Google Maps for villages, that through satellite imagery analysis, you can zoom in on any part of India. So we built this model for all of India. You can zoom in on any part of India. It'll, from the satellite imagery, it'll start identifying things like field boundaries. We are not utilizing land ownership records. We are assuming that the usage patterns correspond to ownership patterns somewhat. So based on the plants that we are seeing and based on trees that might be planted at the boundaries of these farms, And we are identifying all of the field boundaries, we are identifying all of the water bodies like ponds, wells, and so on. We are identifying various trees because it's important for, again, environmental reasons to identify the tree cover. And then we are further, for the crops, we are doing further work on identifying the crop. What is the crop which is being grown today? So today, as we work with the Ministry of Agriculture, what they tell us is today they have separate models for every crop, for every region. What we are trying to do is take that foundation model approach where we build a single model that covers all of India, all of the crops. And so far, I wouldn't claim we have successfully built that model for all the crops, but for at least the top 5 crops that you're typically interested in a given region, we are finding that a single model is providing fairly high levels of accuracy. And the idea is that this can now unlock very powerful use cases like giving loan to the farmer or insurance, right? We all know that often farmers are unable to get loans from banks, so they end up going to loan sharks who lend them at a very, very high rate. Now, if there is crop failure, the farmers are caught in a debt trap, and many of them end up committing suicide and so on. Now, imagine a scenario where instead of having to, when you approach a bank branch, which is maybe 80 kilometers away from your field, you don't need to have the bank send a representative to identify kind of what's going on in your field. Just from satellite imagery, the bank could simply say, okay, I'm able to see what crop you're growing. I'm even able to see historically what you have been doing over the last few years and the kind of yields you've been getting, and estimate what yield you're likely to get at harvest time and then give you that loan. So that could really unlock these kinds of use cases. And in the future, another major concern is climate change, global warming. So there is tremendous potential if we have farmers following regenerative agricultural practices like crop rotation. You avoid things like stubble burning. It improves the carbon holding potential of the soil. So we are also working on a longer term research project where can you, again from satellite imagery, make that estimation of carbon holding potential of the soil more accurate. Because today, the only way to do this is to do expensive lab testing. If you could make that process more scalable, more cost effective by utilizing satellite imagery analysis, you can also start to financially incentivize farmers not to burn stubble and adopt these regenerative practices. So I'm out of time, so I wouldn't take you through all of the details of this work on large language, on efficiency, but one in particular that I wanted to highlight. This is a collaboration. This work was led by one of our researchers, Pratik Jain, together with one of his former student researchers who's currently at University of Washington. So this has been like a multi-institution collaboration where we have come up with this technique called Matformer. And today, what happens is when you build these large language models, you will often hear about discrete sizes. Oh, this model, for instance, even Google, we will talk about, okay, here's a model extra large of the original size is called extra large. And now you have, for efficiency purposes, you also make smaller versions of that model that, oh, we are also making this model available in large, medium, and small sizes. So often these are like a discrete sizes, okay, 300 billion parameter model, 150 billion parameter model, 33 billion, 2 billion, and so on. So why restrict yourselves to only these sizes? This is a truly, again, first of a kind work that we have already demonstrated in the world of vision models, and now we have demonstrated it in the context of large language models, that instead of building all those different sized models separately, you build them in a nested manner so that your small model is contained in the medium model, which is contained in the large model, which is contained in the extra large. And not only that, you are no longer restricted to just these of the order of 4 or 5 variants. You can have hundreds and thousands of variants. And the way you do that is that these transformers, basically just a very quick thing, they have these, think of 2 major components, this multi-layer perceptron and this multi-HUD attention. In this nested Matformer style, this name comes from, we took inspiration from these Matryoshka Russian dolls, right, which are nested one inside the other. So the idea is to, as you build these models, first, all those neurons that you are using in your neural model, first identify them in a certain sorted order. The most important neurons first. The most important neurons are there in even the smallest of the models that you are building. The next set of important models are there in a bigger, next bigger model, and so on. So this is how you build those models. And when you have a bunch of these different blocks, you can choose to mix and match. I can say, okay, for block 1, I'm using a large model. For block 2, I'm using a small size model. For block 3, I'm using an extra large size, and so on. So as you try out these different sizes, now you can have an exponential number of combinations and come up with all of these different models. So now, instead of just those 4 or 5, I can have hundreds of sizes available of those models. And depending on this cost performance trade-off, I can choose which size model. Not only that, now the really interesting part will come in the future. We ourselves have not mastered this part yet, but imagine a future scenario where at runtime, given a query, I decide how much power I need to serve that query. Because if somebody asks me a very simple question, who is Narendra Modi? Even a very simple model, which is only a few million parameters, would be able to answer that question. On the other hand, if the query is, hey, solve this, this mathematical puzzle, and gives a very complex mathematical puzzle, perhaps that requires a much larger model. So given that query, okay, I'll use a more powerful model. Given a simple query, I'll serve it with a very simple model. And also you can, depending on the system load, if the system is heavily loaded, I'm going to use relatively smaller models. If the system is lightly loaded, let me make the full power of the large models available. So through this, once we are able to dynamically figure out how much power to use for a given task or a given query, you can actually dramatically reduce the cost of serving these models. So that's the future that we are trying to now build towards. And what we have shown is that through this Matformer approach, all those intermediate points that you're getting pretty much for free. You just train a model once, and now I'll give you all those hundreds and thousands of variants of models up to that size pretty much for free. All those models have roughly the same power as a custom trained model for that specific size. So that's the breakthrough that we have shown now for large language models. And this we believe can, just like, to me this is analogous to virtualization technology that enable elasticity of compute in cloud. I believe this technology that our team has developed, Matformer, can enable elasticity in even these ML models, the power of ML models being used at runtime, and should enable very significant gains in overall efficiency. So let me conclude that AI is already here in a big way, impacting every industry and the world at large. We've seen this rise of foundation models, which are amazingly powerful. There's still a need to enhance these models and then build further solutions so that you're able to really benefit billions of new people, not just the privileged ones, those of us who are in this room. And And there are, again, many interesting challenges to tackle as you enhance these models to serve billions of new users. But ultimately, my main message is these are amazingly exciting times. I mean, the technology is now at a point where we can, through our work on technology, we can impact so many millions and billions of lives of fellow humans on the planet that, I mean, I can't imagine a more exciting time where through our work, we can have that real world impact. So let me stop here and thank you for your attention.
Thank you, Mr. Manish Gupta. I'd like to request Mr. Srini Raju from Pi Square to felicitate Mr. Manish Gupta with a plaque. Now, moving on to another keynote, we'll be requesting Mr. Umesh Sisodia, CEO of Circuit Sutra, to get ready. Yes, we'll move on to the keynote address of Shift Left ESL Methodologies for AI SoC Design. Mr. Umesh Sisodia is the founder and CEO of Circuit Sutra, a company focused on System C-based Shift Left ESL methodologies. He has 25 plus years of industry experience and worked with semiconductor companies and Cadence before starting Circuit Sutra, and worked for many industry leaders to bring an international conference, DVCon, to India, and was the first chair of DVCon India 2014, and an annual conference being held in Bangalore. Mr. Umesh played an important role in the evolution and adoption of System C in the industry. He is also awarded by the Accelera Systems Initiative for driving the adoption of standards in the Indian ecosystem. I'd like to request Mr. Umesh Sisodia to take over.
Thank you. So good evening, everyone. Can I have my presentation on? Design. So we'll first cover about what are the ESL methodologies, and then we'll talk about how it is applicable for the AI SoCs. So as all of us are aware, I mean, since the inception, the semiconductors have seen the continuous advancement on the multiple fronts, due to which the chips are becoming more and more complex and more powerful. So today we are seeing the application of the chips in the areas like which we could not imagine in the past. And moreover, with the invention of these microprocessors, now in 1970s, the functionality of an electronic device is not just defined by the semiconductor chip, but also the embedded software that runs on top of it. And over the period of time, the proportion of the software that goes inside the electronic device, that has actually significantly increased. So now designing such complex chips is not that easy. So the chip design methodologies have also evolved over the period of time. And we have historically seen that this evolution in the chip design methodologies has come more in the form of like raising the abstraction of chip design. So like initially we moved from the component level design to the gate level design, and then from the gate level to the RTL, Verilog kind of thing. And since mid-2000, we are seeing a new kind of methodologies, which we call these ESL methodologies. So typically, I mean, these methodologies, we can see as a combination of two phenomena. One is like, I mean, hardware and software co-design, so taking care of the design of the entire system, including semiconductor as well as software. And second thing is raising the abstraction of chip design above the RTL. And these methodologies are implemented using the high-level technologies like C++, System C, Python, etc. And through these, like, we can actually create the representation of the chip at various abstraction levels, like virtual prototype, architecture models, high-level synthesis, or even combining various abstractions to create the, I mean, hybrid kind of environment. So with these kind of methodologies, like today, we can have the operations in the chip design, which are not feasible using the traditional RTL to GDS flow. For example, like we can do the pre-silicon firmware development. So we can develop a fast simulation model right in the beginning, even before the RTL is designed. And through that, actually, we can do the pre-silicon embedded software development. We can analyze and optimize the architecture very early in the cycle. Plus, for some like algorithmic centric design, instead of like hand coding the RTL directly, we can implement the functionality using, let's say, C++ or System C, and using some HLS tool, we can actually automatically generate the RTL out of it. And the most important, we can actually simulate the complete SoC level or the system level at a very fast speed in this. So these methodologies, although these started in mid-2000, these are still evolving, and these actually coexist with the RTL to GDS flow. So now let's take the example of this artificial intelligence SoCs. So these kind of SoCs have very specific requirements. So first of all, it have a huge requirement for the huge kind of data processing. Like it will have a continuous stream of data coming from, let's say, sensor or from some other scenarios, which has to be processed through multiple stages, along with a huge volume of AI models, etc. So there is a requirement for real-time data connectivity, and a huge bandwidth is required for the data coming from outside the chip, as well as data flowing inside the chip from one stage to other. That way. Power and performance optimization is very important in these kind of chips. And more importantly, when you are coming up with a new SoC architecture for AI kind of applications, so it is very important that it has to seamlessly work with the popular frameworks like TensorFlow, PyTorch, ONNX, etc. So for designing these kind of new SoCs, lots of innovation today is happening in the industry. This innovation is mainly happening on two fronts. One is on the compute side, and second in the memory architecture. So people are talking about compute for data in motion. Massive parallelism is required on the data level and the instruction level. Plus new kind of innovative memory architecture. People are talking about tightly coupled memories or in compute memories kind of thing that way. Plus lots of emphasis is happening on accelerating specific algorithms, instead of running in the software, these can go inside the chip. Yeah, so let's see how these shift left methodologies can be useful for AI SoC. Yeah, so typically, so let's say if we are conceptualizing a new SoC architecture, which is going to be used for this AI kind of workloads. So right in the beginning, in the concept stage, when we are just defining the functionality, so if we can get a simulation model, which is register accurate, and maybe which can simulate, let's say, 1,000 times faster than RTL, and which can actually run the unmodified software, the software which is going to run on the real hardware, if it can be run on this, in this model. So this kind of model can be very useful to validate your architecture, to validate your initial functionality with the real software which is going to run on it. So right in the beginning, actually, you can actually validate it and find the bottlenecks, if there are any errors in it, if there are any fine tuning you have to do in the architecture. That can be done right in the beginning. And plus, once you have the model available, you can actually keep on using it even after your chip is designed and once you get the real hardware. So even after that, for the continuous integration and maybe continuous development of your software stack, which can keep on changing throughout the life cycle of that usage of that chip, for that actually this model can be effectively used. So other thing which is very important for this AI kind of SoCs is optimizing for the performance and optimizing for the power. So most of these AI chips are going to be used in maybe real-time decision making for the real life scenarios where the latency has to be extremely small and coupled with huge data processing happening. So the performance optimization is very important here. And similarly, power optimization is also very important, irrespective of whether this chip is going to be used for edge devices. So in the edge devices, the small edge devices may not have a continuous access to the power and might be running on the battery. So optimizing the power there is very important. or whether these chips are being used in the data center. That in the data centers, like major portion of the cost today is the power consumption. So optimizing the power for these SOCs again become extremely important. So right in the beginning, when you are defining the architecture, like if we can develop the models, let's say performance models or the power models, and using that we can do some analysis. Accordingly, we can actually fine tune our architecture. So that can actually save lots of cost and time in the long term. Further, like if we have some new algorithms, like most of these SOCs, there is an emphasis on maybe accelerating some of the tasks which were used to be done in software, putting them inside the chip. So the traditional way is to handcraft the RTL for that, but using the HLS, like you can implement the functionality at a higher level using, let's say, C++ and System C, and then using the HLS tool, we can generate the RTL for that. So that way, like we have more flexibility, like we have a software, and we have the flexibility that either we can use it as an embedded software or the same algorithm into the hardware inside the chip. So that we can actually help in more effective hardware and software partitioning. So what are the benefits of these kind of like ESL methodologies? So basically, I mean, it can help in the early identification of, let's say, architecture bottlenecks, the architecture errors on the architecture bottlenecks. So quite early in the cycle, actually, we can identify and maybe fine-tune our architecture quite early in the cycle. So it could be like flaws in the architecture, flaws in the functional specs, flaws in the functionality, or whether it's going to perfectly work with the target application software or not. So instead of waiting for the chip to be designed and fabricated, I mean, if this kind of analysis can be done right in the beginning, so that can be useful. So definitely it can save lots of cost. So we don't have to go through the complete cycle of, again, like designing the chip again, getting it fabricated again. It will significantly reduce the time to market for it. And most important, I mean, when you are still in the concept stage, quite early, actually, you can start engaging with your potential customers and see whether your SOC architecture, which you are actually conceptualizing, whether it's going to be suitable for specific workloads of your customers or not. And accordingly, actually, you can fine-tune and further refine your architectures that way. And moreover, it's very easy to roll out the future variants of the SOC. If you already have, I mean, initially it will require some investment to develop the models of the first variant of the SOC. But once you have this modeling infrastructure already available, then rolling out the future variants of this SOC becomes quite easy for that. So if we try to summarize, I mean, it can significantly enhance the probability of the success of such SOCs. So today, as we know, I mean, most of the leading software companies or the system companies, they're trying to design their own custom silicon for the AI workloads kind of thing. But not all such initiatives are actually really very successful. I mean, if these shift-left methodologies are deployed very effectively, it can actually greatly enhance the chances of the success for such chips. So at Circuit Sutra, our mission is to accelerate the adoption of these methodologies in the industry. We are working in this SOC modeling for more than 15 years now, and we have seen the evolution of these methodologies right from the the research phase to pilot projects and now to the widespread adoption of these. So we actually provide the SOC modeling services through which we set up the modeling teams which work as the extension of the customer's team. We have a highly specialized training, which is System C for virtual prototyping. So we actually package our internal ramp-up program as a training, and which we conduct for select few customers. So this is a highly effective training which can actually make the non-System C engineers to become the modeling experts. Over the period of time, we also developed some reusable modeling methodology, which we call Circuit Sutra Modeling Library or Virtual Prototype Quick Start Package, which can be helpful to the companies who are just getting started with these ESL methodologies. So this methodology can actually act as a very good starting point for them. We are supporting the industry since 2005. We have a team size of around 50 modeling experts with a combined experience of 250 plus years in the ESL domain. We also got the award from Accelera Systems Initiative for driving these standards in the Indian ecosystem. So today I can say that perhaps we are the only company which is 100% focused on these ESL methodologies and which understand all the aspects of these methodologies. So now if we talk about this AI semiconductor ecosystem, so I mean through these ESL methodologies, like we have the capability to become a partner to almost, I mean all the players in this ecosystem. So let's say if we have a processor company, so for the processor company we can support them to develop the functional model of their processor, which we call instruction set simulator, which is a very fast model. Or maybe we can develop the cycle accurate models which can be used for architecture exploration, performance modeling, etc. And plus helping them to integrate these models with the popular simulation environments like Verilog, System Verilog, or with the popular embedded tools. For the IP companies, like we can help them to ESL enable their IPs so that with these IPs can become more valuable to their potential customers by developing the system C models of their IP at a various abstraction levels. For the SoC companies, we can develop the virtual prototype of their SoC, or we can develop the architecture models of their SoCs. For the algorithm companies, if you have any specific algorithms for, let's say, neural network, image processing, video processing, so we can actually accelerate your algorithms using HLS, so that way you have a more flexibility to use that algorithm either as a software or as a hardware. Yeah, so that's all I have in the presentation today.
Thank you, Mr. Umesh Sedia. So may I request Mr. Devender Kaul, DGM Member Relations and Outreach at IESA, to felicitate Mr. Umesh Sisodia? Do we have Mr. Devender Kaul? Okay. There's a general announcement again. There's tea and coffee being technical leadership roles at Xilinx, Freescale Semiconductors, and ST Micro. She has over 21 years of experience in the front-end IP SoC design and architecture. Dabelina holds a bachelor's degree in EE from IIT Bombay. She holds 17 granted patents on various technologies related to IP and SoC design and architecture, and has been a speaker at various industry conferences. I'd like to request Ms. Dabelina onto the stage. And the panelists, Ms. Ramadevi Lanka, Director of the Electronics for the Government of Telangana. Ms. P. Rajalakshmi, Professor, Department of Electrical and Electronics Engineering at IIT Hyderabad. Ms. Surya Prabha, VP at Enterprise of AI Solutions and Cognitive Engineering at Scientific. Dr. Samira Poduri, AI Lead at Uber. Let's give a big round of applause for the women in AI. It's exciting to see this. I'd like to hand over to Dabelina next.
Thanks, Rama, for that kind introduction. So here we are. The topic of our annual discussion, as Rama mentioned, is AI growth and innovation across the industry, academia, and government. So since morning, we've heard quite a few keynotes, as well as we listened to a lot of different panelists or different panel discussions. But I think most of them, if not all, where the panelists where they were coming in from the industry background, from the semiconductor industry and the corporate sector. And our panel over here is different because here we have the folks not just from the industry, but also from the government as well as the academia. So that we get a holistic picture of how AI is penetrating and influencing not just the semiconductor industry, but also the academia as well as the government. So with that, let me get started and introduce our esteemed panelists over here. We have Ramadevi Lankaji, who leads the Emerging Technologies Wing of the Information Technologies, Electronics and Communication Department, ITENC of the Government of Telangana. Her role is to formulate and execute policy frameworks in frontier technologies such as AI, blockchain, cloud, drones, cybersecurity, and others. that would create a conducive ecosystem for the growth and emerging technologies in the state, and to build institutions of excellence and assist the government in leveraging technologies to create impact and improve lives. She's also had a brief stint with startups in Silicon Valley. She holds a postgraduate degree in environmental engineering from JNTU and an executive program in business management from IIM Kolkata. She is a recipient of the Digital India Award from the Honorable President of India and has also received the Women's Achiever Award from the Government of Telangana State in 2022. Welcome, Rama ma'am. Our next panelist is from the academia. Dr. P. Rajalakshmi is the professor in the Department of Electrical Engineering, Science Chair Professor in Future Communications, and Project Director of Technology Innovation Hub on Autonomous Navigation Foundation, Tihan, at IIT Hyderabad. Her research areas include autonomous navigation, drone-based sensing, wireless communication, Internet of Things, and cyber-physical systems, among others. She has been handling R&D projects funded by industry and government of India in these areas. Along with fundamental theoretical research in IoT CPS domain, she also emphasizes on translational research, which involves development of minimum viable product and user-beneficial products. Out of her research activities, she has filed 15 plus patents, published over 40 plus journals, and 150 plus conference-reviewed papers. She was awarded Young Faculty Research Fellowship under Vishveshwaraya PhD program in January 2016, and was awarded the Digital Trailblazer Award by India Today. She is also a member of CII Telangana Digital Transformation and IT panel since August 2018. Welcome, Dr. Rajalakshmi. Our next guest here is an industry veteran. Surya Prabha is Vice President, Enterprise AI Solutions and Cognitive Engineering at Scientific. Prabha has more than 25 years of architecture and leadership experience, providing technology solutions for business-critical and strategic initiatives using various technologies such as AI, ML, computer vision, generative AI, etc. She specializes in architecting and implementing DevOps, AIOps, for disparate technology and domain platforms, including AI-based enterprise solutions. She has worked with multiple service sectors and product-oriented companies, ranging from giants like Accenture to domain-focused product startups, such as Sustain Lane and Nova IQ. She has designed and delivered large, complex digital and AI platforms in financial services, logistics, education, legal, and retail industries. She has also led the design and development of India's first deep reinforcement learning-based network optimization solution and a deep neural network-based legal Q&A solution with a standalone voice-to-text component. Prabha is a dance and fitness enthusiast and holds a master's degree in computer applications. Welcome, Prabha. And our final panelist comes from a research background, but is also a part of the industry now. Dr. Samira leads the AI team for customer support at Uber. Her team is currently focused on developing Gen AI solutions to enhance the quality and efficiency of support experiences. With a wide range of experience spanning recommendation systems, natural language processing, sensor inferences, and robotics, Samira is passionate about leveraging the latest innovations in AI to create compelling products. She holds a PhD in AI from University of Southern California, as well as a BTech and MTech from IIT Bombay. Her work has led to 40 plus patents and publications with 1,000 plus citations. After spending nearly 2 decades in California, Samira relocated to Hyderabad last year. Welcome, Samira. And a quick aside on Samira from me. She's also my senior from IIT Bombay. So I've shared a hostel with her, and today I get the privilege of sharing the stage with her. Welcome, Samira. Okay. With that, let us get started. And to begin the discussion, I would like to hear from all of you a brief introduction about how you entered into this field of AI and ML, which is relatively still new, let's say. And how was your venture like? How was your journey like? So let's start with you, Prabha.
Yep. Thank you, Debelina, for the introductions, and nice to be here with all the distinguished co-panelists. My AI journey started about 6 years ago when I started heading an AI startup, and I was heading the India branch for that. And primarily the startup was focused on providing bespoke AI solutions, unlike many of the startups which were building some products around AI. Primarily, because by then I had about 20 years experience in building enterprise solutions across different tech stacks. Back in 2018, the adaptation of AI was very low. In the sense, businesses were actually trying their hands out and see how AI can help in their business development. And that's when the startup, as I said, which was focused on bespoke solutions, we started on the first on the consulting front, where to actually handhold the different enterprises, how AI can help them, what is that insights that the data is holding for them, what are the different optimizations that they can do. And as part of that, one of the solutions that you already mentioned, building network optimization solution with the deep reinforcement learning. So this was the journey primarily to focus on helping AI to step out, research labs and actually get into the business application world. And my journey still continues in the same pursuit.
So I started a very long time ago. So as an undergrad at IIT Bombay, I was part of the robotics group, and we used to have this large six-legged walking robot. It was called Nataraj. And my first project there was to design gates for this walking robot. And that was my first foray into machine learning. In fact, we used reinforcement learning. And that's how I got introduced. This was 2001. And after that, I did my PhD in mobile robotics, working on navigation algorithms. And over time, I sort of shifted more towards the algorithmic side. As I moved to industry, I was more interested in developing consumer-facing AI products. So I worked at a couple of startups. I worked at Qualcomm, so I worked for some time on ML at the edge. And then now that with Uber and Uber in India, I started the machine learning team working on conversational AI, chatbots, and generative AI. That's been my most recent focus.
Thank you, Debolina. Well, I've attended many events and, panel discussions, but this particular one is very special to me. All of you know why, because in each one of them, are doing great work in AI. It's all women, AI panel. Well, maybe down the line, 3 years down the line, or probably 5 years down the line, this should not be a special, event as such, but it should become so common that probably we might think, "Arey, thode men ko bhi le lenge," something. So yeah, coming back to your question, actually, it has been an incredible journey for me, for the last 6 years when we started off this emerging technologies wing in Government of Telangana. So we actually presented a portfolio of technologies to our Minister, Honorable Minister of IT, saying it started from, AI, blockchain, cloud, drones, robotics, and so on. So it was in 2018 when we actually presented this to our minister, saying that these are the technologies that the government would focus on. So in 2018, again, we followed these waves of technologies, It was 2018, it's all blockchain, wherever even, like we organized an international conference on blockchain. Tim Draper was also here. So that entire year was kind of, taken over by blockchain. The second year, it was again drones. It was, India. It was like everywhere you started hearing about drones making. So the second year, 2019, we actually, focused on drones. And 2020 was the year. In morning, Jesh Garu was also mentioning about that, So we commemorated the entire year as Year of AI. We just kicked off on Jan 2nd, just Jan 1st was New Year Day holidays. Second, we started off this Year of AI initiative. And it was 2020 and now 4 years. It has been a great journey. We actually implemented, I would say, put in an ecosystem enablers in place, in the sense we made data available to startups, the ecosystem. the data that's owned by the government departments. We actually set up a data exchange platform, where data is available. You don't have to ask a department to get the data. Of course, initially we did it for agriculture sector. You can just get onto the platform and, download the data based on certain contractual agreements. We came out with the policy framework to share data, enabling even private data to be shared. So these are ecosystem enablers. Second, driving innovation through implementation of very innovative use cases within the government sector. As Jayesh Garu mentioned in the morning, we are working on more than 25 projects and making a difference in the lives of, it could be a farmer, it could be a student, it could be healthcare. And under innovation, we also have a program called RevUp, which is an AI-focused accelerator where we have 140 startups, that are availing various services from market access to, like VC roundtables, IP enablement, and so on. And this is actually being run by Telangana AI Mission, which we set up in partnership with NASCOM. And the third one, skilling, is again, we have taken up, we have trained so many students because that's our focus area. So it has been a great journey for us, and along the way, today I can proudly say that Telangana, among the Indian states at least, Telangana could be rated as, of course, Bangalore has always had that advantage of an early beginner, but we have done so much, within the government organizations. I don't think any government has done that much. So, and along the way, we have won many awards, accolades and recognitions. As Develina has mentioned during my introduction, one of our projects has won an award from the President of India. Well, it has been a great journey. And this could be possible because of the partnerships, various partners that have actually supported us in this journey. Yeah, thank you.
Hey, hello, hi. This is Professor Rajalakshmi. I'll start from 2009. It was a very early stage of IIT Hyderabad. We were the first one to get a hub on, cyber physical systems. It was a large funded project by MIT, and I was part of the project as well, where I was working on smart homes, energy efficiency and things like that, integrating sensers, coming up with AI/ML stacks for energy efficiency, where, it was a very early stage of, I would say, prototype development. We had some proof of concept, labs which are very energy efficient, saving up to 30% of energy. Starting from there, we had multiple projects, again, in the area of, in different application areas. I would say one of the other flagship one is a healthcare project, which was an Indo-UK project. Again, it was, automated diagnostic tool. You using ultrasonic sensors, which are non-invasive. And, that was again one of the flagship projects, where we have come up with automated diagnostic tools. And going forward around 2015-16 time frame, we had another funded project by DST, again with Indo-Japan University of Tokyo. Again, that was fully on drone-based sensing. Here, the phenotyping. Particularly, we had worked with Professor Jaishankar, Telangana University, and we worked with ICRISAT, where we used very high-end sensors on drones, coming up with end-to-end automated pipelines, for not only RGB, but also with multispectral and very high-end sensers like hyperspectral even, starting from 400 nanometers to 2500 nanometers, working on water, nitrogen stress analysis, automated pipelines of the data which is acquired from the drone, which is ongoing now. And the most, again, very important flagship project of IIT Hyderabad is again a technology innovation hub on autonomous navigations, which again from the DST, under the National Mission on Interdisciplinary Cyber Physical Systems, IIT Hyderabad was awarded on navigations, autonomous navigation data acquisition. So under that hub, we have set up, I would say, the first of its kind test bed on autonomous navigations. We have a test track or a proving ground where you can test the autonomous vehicles in real time. Okay, so that was one of the major achievements, I think, an academia in the Indian context have a proving ground for autonomous vehicles. So when I say a proving ground, it has all the facilities, starting from, different types of tracks, like three-lane road, two-lane road, intersections, signalized, unsignalized, all kinds of things that, sharp S-curves and other things that an autonomous vehicle will have to maneuver automatically. Okay, so then we have, different kind of radios. We have smart poles with different kind of radios, starting from Wi-Fi radio, 5G, connected vehicles. So such all kinds of, infrastructure which is required to create an autonomous navigation, both drones based as well as ground-based vehicle have been set up at IIT Hyderabad. Recently, I would like to also brag about saying that we are the only campus in which we have launched an autonomous campus shuttle in the campus itself, which has evolved out of the last 2 years of research. Anybody who is stepping into IIT Hyderabad will be able to shuttle on an autonomous campus shuttle from the main gate to the hostel circle. Every day, each trip is around 7.5 kilometers, which is fully, autonomous. You can see no driver sits there, it is autonomously flying, and everybody who steps in can, navigate inside the campus in autonomous campus shuttle. So that way, we are doing a lot of autonomous research, I would say AI, ML based research for different applications. So that's how the journey of AI is with me in IIT Hyderabad.
Thanks a lot, panelists. It was so interesting to hear all these diverse backgrounds. I mean, some excellent examples that we heard already. So I'd like to start a question with you, Professor Rajalakshmi. And since morning I've been here and I'm hearing about all these, amazing advancements and the new algorithms, new applications that are coming up. And I sometimes wonder that the students that are taking up AI as their domain or subject, how are we ensuring that they're going to stay relevant after 5 years, in the industry? So, how do we ensure that?
So I think, we are actually creating a scenario where AI should be like replacement of everything, which is actually making AI more and more, I would say, wanting for more and more advanced AI technology. As a result of which, I think, whatever we are doing now is really not sufficient to actually handle the futuristic problems. For example, we want something, a humanoid robot which is actually replicating the human itself, in scenarios which are very hazardous. Okay, so which is again, we are moving towards generative AI, which is huge compute. At this point of time, most of these large models work in heavy servers. So how to port such large models in edge is the biggest challenge, which needs to be solved in next, I would say, maybe 5 or 10 years down the road. So we are still more hungry to do a lot of research going forward in AI.
Awesome. That was nice to hear about some hardware. So, Rama ma'am, a question for you. How is that, you did talk about Telangana government having multiple initiatives starting from 2018 onwards, but can you talk, maybe take a few examples and talk about how AI is penetrating into the various Telangana departments as such, and maybe even a little bit about the roadmap of what all we want to enable with AI in the future from the government perspective?
Sure. As I mentioned earlier, we are working on more than 20 projects, related to about 10 sectors we call departments within the government. And these sectors or departments range from agriculture, healthcare, education, forest department, transportation, and so on. And we have a very structured approach, when we actually execute these projects. Like we brainstorm with the departments on various problem statements, trying to identify pain points that can be addressed by technology. And once we do that, we try to identify a perfect solution for them, scout for solutions offered by, it could be enterprises, it could be, startups, innovators. We scout for a solution and actually then implement it as a pilot so that the department gets confidence, okay, this is working. This in fact gives the benefits that we are expecting. So once that's the structured approach that we do. And the kind of projects that we have done so far are really amazing, that really touches the lives of, as I said in the beginning, it could be a farmer, it could be a student, so, and even a citizen. For example, we started off initially AI, in identifying or authenticating an individual, because most of the government services that we offer requires verifying if a person who claims to be so-and-so is really that person. So that we actually initially, for example, to get pensions, a senior citizen will have to submit a life certificate that you have to submit a proof of certificate saying that you are alive. And this poor senior citizen will have to go to a government official, or a gazetted officer they call it, or some authorized person to get that certificate signed wherever he is. He may be in US, wherever, but at that point of time when he has to take a pension, he has to get that certificate. We made it very easy by, now most of the organizations are doing that. SBI recently did that. But we did this almost 3 years back, A person has to now just take a selfie and in an app, and that actually compares, whether this particular person is in the pensions database and is this a live certificate, and now pensions are being dispersed that way. That's one example. The same, solution is being extended if you're actually applying for a renewal of your driver's license. You don't have to visit a transport agency, RTA. And that we further extended, because this election time, I just want to mention this, for e-voting. We developed a smartphone-based voting app. It's really so good, when we actually rolled out in Karimnagar district, the users just loved it. Because Election Commission of India, in fact, they came to us and said during COVID, can you help us in developing an app, to help these COVID patients vote, or even senior citizens who cannot go to a physical booth. But that got extended to everybody. They said most of the urban voters, they're very reluctant to go to physical booth and vote. So can we make these urban voters vote, is what they asked. And we have set up a committee by Rajat Mona, Professor Rajat Mona. He was heading the technical committee, and it's an excellent solution. Even other states actually came to us and tried to understand. Of course, it's again the political will, that will implement. That's one. Second, in agriculture, we are doing something really great, where we are deploying a range of technologies across a particular crop, chilies. In the phase 1, we did that, we deployed AI for quality assaying, AI for soil testing, which won an award of, then market discovery and so on. So at the end of one crop season, we actually carried out an impact assessment and came to know that it actually increased the farmer's revenue by 20%. So that's another kind of, I can go on and on, And morning, Jayesh Garu actually shared about the forest department use case, that we are actually scaling it up across the state. And the last one that I would like to share is about transport. Of course, tomorrow, I think Varma from Intel, INAI, is going to talk about it. We're actually implementing ADAS systems, to prevent accidents, to reduce accidents by 50%. Well, these are the kind of, range of solutions that actually, help citizens or even, make a difference in the lives of a common citizen or a farmer. And coming to your second question, where you said whether we have a roadmap. In fact, today morning, I don't want to repeat that. Today morning, Jayesh Garu gave a very clear, progress of our implementation framework. We actually come out for each technology, including AI, blockchain, anything, we come out as a policy framework where we identify key pillars, where the government should focus on. That is kind of a strategy document for us. And today we can proudly say that, as he mentioned in the morning, 80% of what we have envisaged 4 years back, we could actually, achieve it. So now probably we need to again relook at it and see. But when we, even now if you relook at it, the same pillars hold good, I think. Except now how do we actually use Gen AI, how do we integrate that into our projects is what we are looking at. Yeah.
Wow, those were really interesting examples, Rama ma'am. And, it tells me that, if such a powerful AI tool in the hands of the government can truly make AI pervasive, right? Bring it to the last leaf level person who really needs this. Thank you. Thank you for that. Samira. Yeah. A question for you, Samira. Can you talk a little bit about how AI is penetrating the various consumer services? And I know that you've been working in the field of responsible AI, so also a little bit about why we need responsible AI.
Yeah. So we heard a lot of the, the discussion earlier today, right? Like the areas that I see in the consumer space, you have content creation, be it for marketing, advertising, or entertainment, multimodal text, image, video, and so on. That's one area. The other area is with chatbots and conversational AI, providing automated support experiences. You may have an automated salesperson or even an automated teacher, right, to some extent. So that is another area. And then the third area is efficiency. So whether it is developer efficiency or analytics efficiency and so on, right? Like, so these, there are many others. I think we are clearly entering a phase where AI will touch upon pretty much all consumer services, and customers will come to expect that. But these are the broad pillars, and you can see these themes throughout the day today as well, right? Now, in terms of responsible AI, like Dr. Manish went into detail, right? That was, I think I totally agree with that approach, where when you're looking at consumer products, right, there are a few things you have to keep in mind. One is that, like something with AI and consumer products, right, there is always a long tail of what the things that can go wrong. So if you take, for example, autonomous driving, right, like we had, like as an analogy, right, like we had cars that could drive in 2005. Right, we had demos, we had DARPA Grand Challenge successfully completed around 2005, but it's taken us so long to get to cities, and that too in limited cities in the US. Now, why is that, right? Because it's in AI, it's very easy to create a prototype to get the 50% use case right. You can do it pretty much out of the box, but your real work begins then, to go from that point to take care of the long tail. And when it comes to the consumer products, you have to think about what does that tail problems, right, the tail error cases, what impact will that have on your customers? And how are you going to mitigate that, right? Like if you have a chatbot, what happens if it hallucinates? What happens if it says something just incorrect or inappropriate, or something that is not in line with your policy? These are all the things you have to worry about, right? And then, of course, like what about the bias? Does it show a bias? And do you understand what it's saying, right? Like, do you have the observability? So that's where the real work is with consumer products, right? And so the way you handle that is, Dr. Manish mentioned, having a human in the loop is a great way. If you're able to do that, you should do that. You need to have a really rigorous evaluation and observability system. Right? How are you evaluating? One interesting technique that's coming up is that you use more superior large language models to evaluate the smaller large language models. So if I'm going to deploy a product using Google Bison model, I'll use a GPT-4 to evaluate my Bison model. And that's turning out to be a very successful approach to scale evaluation. There are various ways to observe and explain what you're building, the responses that you're giving, and so on. So, and then of course bias mitigation and so on. There's we talked about how these models are trained by certain demographics, data that belongs to certain demographics in certain parts of the world for certain languages. So how well does it represent the rest of the world? So thinking of those biases and so on, it becomes really important. And these can make or break your products, right? So it's it cannot be an afterthought. You have to think of that before you start developing your consumer products.
Wow, that was really good insight, Samira. In fact, I now see that maybe 6-7 years down earlier, nobody was even talking about responsible AI, and now so many of the conversations are around that. So clearly people have understood that this is a key part of the product design itself, and it has to be thought through from the very start. Yeah, thank you for that. Prabha, over to you. Given that you come from a services sector which is more in the B2B space, can you talk about the kind of challenges and problems that your customers are coming to you with, and what are the new innovations you're working with? What can we expect to see in the next few years?
Yeah, when we build the solutions for business, bespoke solutions, right, it's a little different ball game when it comes to product, right? Product, we will try to make it as generalized as possible. Here we have to make it as specific as possible for the customer's problem. So the kind of challenges that we talk about, right? I'll go back and mention again. The challenge that first I have resolved is for a logistics company where I had built a network optimization solution back then in 2018 using deep reinforcement learning, where reinforcement learning was only being used to build video games. But then how do you apply it for that? Because a reinforcement learning solution is something, a kind of an AI model that you can teach any business process to it and make it as a smart virtual assistant for you. So the kind of problem statement I was dealing with, how do I optimize a network of 38 hubs in a country, and how do you create, there will be like millions of combinations to come up with something so that you operationally make it efficient. So when you talk about these problems, they say, okay, my problem is that I need to bring down my cost of operations. Cost per kilogram is a metric that the customer used, and say you have to bring it down less than 2 rupees, which is a target that I need to achieve, right? There is no specific target, it's a minimum. That means I cannot settle at the local minimum, I have to go to the global minimum. So these are the very specific complex problems. And when I come to the retail sector, right, shrink is a huge problem in retail sector, that is shoplifting. People lose a lot of revenue in the retail sector. So one of the customers for whom we have built a solution, which is the shrink at checkout, self-checkout. People actually come up with 10 products, they pay only for 8 and walk away with all the 10 products. So how do you get to this? So these are the specific problems, and the problem size is so huge that across the US they had about 1,700 stores, and the shrink value is about $350 million per annum. That's the huge revenue loss, right? So we have built a computer vision based solution where you put a camera and count the products when actually the transaction is happening. And other complex problems include shrink at aisle, right? People actually pick up products and drop in their bags and pockets. How do you do this? And it's definitely not a cost-effective solution to have somebody watch over these people all the time, and it will have to be. So that's where AI comes into rescue, and see how you can actually leverage all the advanced techniques that we can apply in computer vision. That a few of these examples. And coming to what kind of new technologies we are going to see. As Dr. Samira mentioned already, AI is everywhere, penetrating in every walk of life, every phase of life, and every corner of life. So in that way, it is more to do with multiple aspects. So I talked about one example where we were processing the video feed, which is computer vision. Actually, now I have to combine it with some text input as well. It's like the future is for multi-model architectures, where a single model will have to comprehend different types of data, not only the text, but also vision, image, video, and all. And to the point which is already mentioned, the edge devices, and right. Everything has to run on a very small infrastructure. That is, our smartphones is something that it has to run everything. So the new technology roadmap talks about how efficiently we can run the most complex things as one uniform, single model which can do a lot of AI tasks, and also run in a very constrained hardware space. That is the where all these things converge together and have our roadmap for the next new technology stack that we are looking at.
Wow, thank you. That was a good insight on different kinds of problems. Now, I actually have a whole list of questions to ask such great panelists over here. Unfortunately, the time has run out on us. So I'm going to do a little thing. I'm going to ask the same question to all of you, and I would like to hear, maybe a brief in response from all of you. And my question is that, in general, across academia, across government and industry, How do we see India faring? So maybe let's talk about the research that we're doing in our colleges. How does that compare to the research that's happening in universities outside? And how does our government compare with the kind of the policies or regulations that other governments are making? And obviously, we would also like to hear about the startup ecosystem in India and how does that compare with the industry outside. So maybe I would like to hear from all of you before we close this session.
Okay, so from the academia perspective, all the funded projects that we are getting now, have this angle of what is the translational research. That is an important component that the government is actually looking for, which is actually leading to more number of startups, industry interaction. Translational research cannot happen unless you see a light as commercialization, which is possible only through industry interactions and startups. So that way, I think government of India is now pushing even academia to get into translational research, which will actually put us, I think, in a global map in many of the areas in the next one decade or so. I think we are leading already in some of these areas. I think biotech is one of the during COVID, I think India was a big pioneer in biotech. I think we will be also setting a lot of examples in AI ML research area because there is a lot of thrust from the government, even in academia, R&D institutes, to put translational research as the as our primary priority area during our research. So I think we will be going a long way in global setting as well.
I think two areas I can see where India can actually, lead the world. One is our country offers huge size, scale, and diversity, So any solution that we build for India can be taken to the world. In fact, one of the solutions that we developed as part of our agri-tech initiatives was actually deployed in Kenya. So that's one. Product and solutions built for India can be taken to the world. That's number one. Second, we have a huge demographic dividend, right? So India can become a talent hub for AI. So in fact, a McKinsey report or McKinsey partner has already said that 15% of the world's workforce will be from India. So I think that's another area that India can lead in the world.
Okay, I have a personal take because I just moved back from San Francisco, where it is like the, considered like the hub of all the AI activity, right? I moved from there to Hyderabad. I think I am actually, I think there is, the ecosystem, I think there is a lot to learn. But at the same time, I'm amazed by the rate of change that I see, particularly in Hyderabad. I'm from Hyderabad, so I have a bias, but I think the rate of change, like, the Telangana government is doing, the startup when I go to T-Hub, So I am very excited by the change that's happening. I'm also seeing more and more of the talent wanting to stay in India, the AI talent. Right, wanting to come back. The number of people who've reached out to me asking for what's the experience been, I want to come back to. So I think that shift is also happening. So I'm actually very excited about it.
So I have to say that we are all biased for Hyderabad.
That's good to hear.
Yeah. Actually, I would like to add, to whatever everybody said. I completely agree. I would like to borrow a couple of words from Mr. Sridhar Vembu. I have been part of the AIML Systems Conference a couple of weeks ago. And then he mentioned how India can actually lead, because we produce 23 million babies a year. And, who actually can beat us on the workforce, right? As Rama ma'am mentioned, the skill is actually, core skill is here. And I'm also part of the Telangana AI mission, where we are, incubating a set of startups who are actually doing some Gen AI. I got to see very closely the kind of research appetite, the kind of challenges, the problem statements that these startups are taking up and solving. It's India, and especially probably Hyderabad, I'm also biased towards Hyderabad, will be the hub of core innovation and research, specifically in AI. backed up by the kind of academic research that is happening. I have also happened to listen to, Professor Mitesh Khapra for AI for Bharat. Building foundational models for 23 Indic languages. That's the research happening in IIT Madras. And the kind of research happening in the healthcare. There are multiple research programs actually part of Google Research India by Professor Milind Tambe, and also by Professor Sanghamitra Bandhopadhyay. She's from IESA Calcutta. The core research that is happening actually is setting the way forward for the world to follow. So I don't see that the future is not very far, where we become the epicenter of the innovation and research in the fields of AI and technology.
Awesome, awesome. Actually, I'm very excited to listen to all of you, and it gives me a lot of pleasure to see that we are in the center of this this AI storm as it is taking place over here. And I'm very hopeful, and I'm hoping to see that in the next few years, Hyderabad will be in one of the top, few cities that are just driving this innovation forward. With that, I think, unfortunately, because the time is up, we'll have to end the panel discussion over here. It was absolute pleasure talking to all of you, and I wish we had more time and we could speak a little bit more. But thank you all for joining us over here. Thank you.
I request you all to stay back on the stage. Yeah. I think just to give you a background why this Women in AI panel, I think I should thank Ramadevi ji. When we started putting together this program, said we have a lot of women, but we don't see them speaking at the conference. I will put together a panel and do it. I think all the credit goes to her. Thank you, Andy. Thank you. So I request Debalina to felicitate Ramadevi Garu. And Professor Rajalakshmi. Surya Prabha. Yeah. Surya Prabha, please. And Samira. I request Rama, both friends are meeting again on the stage. The next session.
Maybe you should take a photo op.
To please stay back. We have a banquet dinner in maybe after one last keynote to go. So another 20 minutes more, and then please join us for dinner.
The last keynote address for the day by Dr. Ganesh Devraj, founder and executive chairman, Soliton Technologies. He's going to talk about the generative AI in semiconductors. Dr. Ganesh Devraj is founder and executive chairman of Soliton Technologies, a leading global provider of software solutions for semiconductor design verification, validation, and RTM workflow automation. Over the past 15 years, Soliton has gained the distinction of being the successful implementer of post-silicon validation standardization solutions for global semiconductor companies. In the afternoon, whoever has stayed in the panel, you probably heard, he's spoken quite a bit about how they're bridging between the EDA companies and what their solutions they are providing. It was pretty insightful, actually, if you've heard that. Dr. Ganesh Devraj has received his master's in EEE and PhD in physics from University of Michigan before working as a project scientist in Michigan developing automated testing equipment for the automotive industry. I now request Mr. Ganesh Devraj on the stage and to take over the keynotes.
it working? Okay. Let me first start by thanking IESA for this opportunity to speak to you all today. So I'll be talking about generative AI in the product development lifecycle of a semiconductor. So there is a lot of talk about, not only a talk, but there's belief in a lot of the CEOs of Fortune 500 companies and more widely that investments in AI are going to pay off substantially. But there is, while there is that belief, there is still a lot of question about when should I start and what should I do, right? So given our own experience over the last, particularly in this 1 year where we have focused quite a bit on generative AI, I want to talk to you about what we think our recommendation is. So just a brief about the company background. So we've been in business for 25 years, serving a global client base, particularly the semiconductor companies. We have strong relationships with 7 of the top 20 semiconductor companies. And we're very proud about the industry-leading customer satisfaction scores that we have today. And if you see our background, it's been in test and measurement, but more particularly in post-silicon validation. So that is 17 years where we have spent in that area. And more broadly, product development work, that whole workflow, we've been focused on software around that space. And we have done multiple global standardization initiatives for big major semi companies very successfully. And what we are now doing is incorporating AI into the automation that we're building in more traditional ways in the past. So the big question, of course, is AI and ML is not new. At least for the last 10 years, there's been a lot of talk about it. But if you see where the gains have gone primarily, it is to companies like Google, Facebook, Amazon. Those companies who had a lot of high-frequency data from their customers, millions of customers coming in, and they were able to turn all that information into very valuable things that they could do with ML and AI. But if you look at it from a semiconductor industry point of view, the benefits have been there. I think we've heard about them, but it's been more limited in relation to what these companies like Google and others have been able to do. But, and will it be different with generative AI is the big question. And what we want to highlight today is, we think with generative AI, there is a big paradigm change. Even today, I was having conversations with people where the question was all about, is my data really valuable in a machine learning context? Is it ready for the training? And what we want to highlight is, with generative AI, we are no longer talking about training models. There is a space for that, but today, with generative AI, with the large language models, which are already pre-trained, we don't have to do any more training. It is about using your data as context, and it's able to provide responses without any training there. So all of your data, as they are today, is useful in the context of the new, in this new paradigm. And our whole message today is, instead of focusing on training models, I think we have to start focusing on training users. Because we know that generative AI or large language models particularly are prone to hallucination. So, I mean, we use ChatGPT, for example, and find that, sometimes the answers are amazing and sometimes they're wrong, right? So, it is about now learning about where to use LLMs and where not to use it. And that will only come through experience, right? It is not going to come if we are just sitting back and waiting. But once you start using it, you can actually figure out where it will work and where it will not. But even more importantly, our recommendation is today, use generative AI only in situations where you can immediately assess the correctness of the answer that you're receiving, right? Not in situations where you are left uncertain, okay, is this really right or not? For example, a lawyer used generative AI and created a big, argument, and inside it, there was a bunch of stuff that they didn't know, right? Those are not the places to go and try generative AI. And also, the technique that I'm going to show in the demo that is to follow, we are able to actually not only get responses, but get responses with references that you can immediately validate by going in there. Once you realize, yeah, this is the answer I'm looking for, I can go into the document and really check it out fully. So how do you get started? If we embed a few AI engineers with your users, and they have to work in a very collaborative fashion to build the tools that are needed so that they can start trying out this new technology. And once we start the process, we believe that there is a virtuous cycle of continuous improvement that is possible. So what is that virtuous cycle? It's essentially very simple. We have to think about the right ratio. We think at the beginning, maybe one AI engineer for every 5 users, and over time that ratio will get to 1:10 or even lower than that. But initially, it will be a very high-touch environment where they have to be really trying out a lot of experiments. So the AI engineer is building safe tools for the users to try out. The users are trying it out and then figuring out, they're building that intuition for where to use, where not to use, and giving feedback and ideas back to the AI engineers. And this is a cycle that has to go on, and it will take months and possibly even years of continuous improvement that can be actually attained. And the AI engineers, of course, have to keep a very strong watch on this fast-moving ecosystem of all the developments that are happening there, and to bring that into the thing. Of course, as a company level, we have to build the governance that is necessary for what kind of experiments can be run here. And the team of AI engineers are also responsible, that's what we are doing with our customers, to measure and report the ROI on a quarterly basis, right? So that is very important, because that's the other big question. I'm making investments, am I really getting returns, and when will I get it? So the demo that I want to show now in a form of video clips is basically around the chip design validation workflow. And we are using the LLM that we are using is GPT 3.5 Turbo that is from OpenAI, and we're using the API to actually access it. And the entire technique that I'm showing here, all the demo that I'm showing here is using a technique called retrieval augmented generation, right? And in this technique, there is no training that we need to do with our data for the AI to work. It's zero shot, meaning you are able to ask a question with context and get an answer, and no, you don't have to send the data for any kind of training, and all the data stays private, right? So there is no training done on the data at the OpenAI side. So OpenAI is, if you're using it through the API, the assurances that your data is not getting stored there or used for any kind of training, right? So it is protected. Of course, OpenAI is not the only solution. There are lots of other options that we can use for the LLM itself. So to show this demo, I am actually using our internal tool that we have developed. It's a tool that we are calling Veena. It's an AI co-pilot for test. And it's basically a browser running in a browser. And what we have done, I mean, this is just one possibility, right? There are so many ways in which we can actually run this same kind of capability. So let me move into the videos itself. So in the product development lifecycle, what is the first thing that a product engineer would want to do? Let's say I'm engineer without much training. I want to I want to start by finding the product specs for the device that I'm going to be working on. So I'm typing in, show me the specs for LDO 2023, just a name that we've given. So it's immediately coming back from our own documentation. It's coming back with the specifications, and it's actually got the specifications showing over here. You can review the specifications, in this interface. And you can go back, and it's giving a link to where it found this information, right? So you can click on that link, and you can go back to the full document from which it actually picked up this information. So you're not only looking at the LLM's summary, but you're looking at in this case, it's not a summary, it's actually just extracting that same table and showing. But it's also giving something very interesting. It's saying, this is a release version, but there's a revision that is under review. Right? So this is a standard problem that we have in the industry, that there will be something under review that we don't know, and I'm already starting to work on something that will get updated and I will not even know about it, right? So these are the kinds of things we believe we can very well solve with with this kind of LLM that's keeping track of what's going on in your organization and reporting it when you need it, right? It's not coming as an email that I will ignore, but this is the time I need to know this, and I'm getting that information. So next is, I want to perform one particular measurement, and I want to figure out how I will do that particular measurement, right? So I'm assuming I'm a novice validation engineer. I'm typing in saying, show me the setup for the line regulation test, like or the measurement. So it's going again into the database, the content that I have, it has access to, and it's pulling out the required information. It's showing me the list of instruments that I would be using for this particular measurement. And, showing that, what are the various SMUs and the DMMs that are needed. And it's also pulling the, from the documentation, it's pulling the whole setup diagram that it's actually showing here, right? So I can look at it, I can get a sense of what is needed. And again, if I want to, I can click on the full reference from which it obtained this document. And it's a document that is where inside my company, so I can actually look at that full document and get the required details. So if you see, it pulled that section out of a section called system setup, and it's pulled that information and it's showing, right? So next, I want to look at, okay, I know what instruments I need, but are they actually available in the lab, right? So I'm clicking, I'm now going to actually ask a question saying, are the instruments that I need for this measurement available in the lab, right? So now Veena is actually going into the asset management database, right? It's querying the database to figure out for the specs that I have of the device, what instruments are suitable. Of course, there are many techniques by which we can actually do this matching, but once it does that, it pulls out the list of instruments that are both compatible for my test and their availability as well. It will show saying that, okay, this is available from this date, this one is already available, and if something is in use, who's using it and when will it become available, right? So this is all coming out of the that query. Now I want to actually make some reservations because I see some instruments are available. So again, I'm not leaving the chat interface. In the interface, I'm saying, reserve this instrument for me, right? So once I type it in, it's making an API call into the portal and then giving me a response with a confirmation saying, yes, this instrument is now booked for you. I said make it till the end of November, so it's actually, and it's showing me the confirmation as well. Now that particular reservation is recorded in the system, right? So it's giving me that confirmation as well. So here again, I'm highlighting what I'm asking the generative AI to do. I am able to confirm then and there that it's actually doing it, right? I don't have these kind of questions, right? Did it actually do or not do? So this is the way in which to use the LLM is what we are trying to highlight here. So next, I want to write the test program. Now this is typically a pretty large activity that takes quite some time to do. So what I'm showing here is we have Veena plugin into the framework that we typically use for writing the test program. So this is a framework from National Instruments called Instrument Studio. It's a part of their Measurement Link framework. And we have actually embedded Veena into that. So with that, what we can do is, so I'm showing now what we are doing here. So we have created a small interface where I'm typing in plain English saying line regulation measurement for input voltage 2 volts to 5.5 in intervals of 0.1 with a load current of 0.1 milliampere with a stabilization time of 2 seconds, right? And where to log the results is also something that I'm saying over here and what to log as well. So once I do that, I click a button called retrieve. And what retrieve does is, it's going into the documentation again and finding the full procedure for this particular program. And it's putting in all the context that I supplied in that text box into this full procedure. So it's a procedure, detailed procedure written in English with my inputs now incorporated. So I can review that. And now when I'm convinced that this is correct, I click a button called generate. And it's now generating a detailed Python, executable Python program for that entire instruction that was written in English. So now, here is a place where we are getting about 80% accuracy. Sometimes there are bugs that we need to go and correct. But if you look at it, the time it takes to write a program of this size, okay, it's showing me timeout, but I hope I can finish soon. A program the size, we are doing it in a much shorter time interval. And now I can click on a button called run, and it's actually able to run that program and give me the results right then and there, right? So I can look at it. So now, once I have finished this, I want to analyze this data that I've just collected. So I'm going into Veena's Analyze tab. So I click on, I know where the data file is, so I'm pulling it, I'm dropping it into Veena. The moment I do that, it's able to analyze the format of that whole data file, and it's putting a plot for me right then and there. So it's picked one choice and doing it. But I'm saying I actually want to group data by load and create a line plot for it. So it gives me the answer, the response that I'm looking for. So now I'm still not too satisfied. I'm saying, okay, I want to improve on the fact that it doesn't include the units in the labels for the title axis, and then I want to improve the title for this plot as well. So I am again typing it in, right? I'm not opening any interface to doing all this. I'm just still within the chat interface. I'm doing that. I click on, when I send it in, and I get the response that I'm looking for. So now I have this, but I want to actually send it as a report to somebody else, right? So I've created a slide, and now I can make a PPT file out of this slide. So these are all just tools that we have, simple automation that we have built within the Veena interface. So now that PPT is available, I click on, send that PPT by email to somebody, right? Now, it's not a static PPT file. It is a static PPT, but within there, I've given a link to get the reviewer back to the Veena Analyzer interface if they want to, with the full context available. So they can come back and interact with the same data that I was interacting with till this point, right? So finally, instead of all working within the Veena interface, you may want to work within a Jupyter Notebook, which is a much more very popular tool, right? So I'm showing here that you can actually export that entire session that you ran within Veena. You can export it into Jupyter Notebook. So yeah, so there is the export, and once you have exported into Jupyter Notebook, you can open it over there, and the full context of your session is available within Jupyter Notebook now. Now, at this point, we want to do something further. What we have done is we have created an interface to our generative AI, the whole Veena, through an API call. So I can say now, Veena.ask, and then I can put in the same kind of queries I was putting in chat. I can put it in Jupyter Notebook as well. And now it is, Jupyter Notebook is querying Veena, which in turn is querying and getting the results and bringing it here. And we have created a full Python library that will enable you to work with all the data structures that are coming back from Veena that you can work within Python as well. So I hope with this whole, quick demo, I did rush through it to keep it within the 20 minutes. I hope I've given you an idea of what kinds of things we can do with generative AI today, and we can do it mistake-free, right? And program generation, of course, it's a large exercise. There are things that you still need to look at. And what finally, we want to summarize in this manner. Generative AI, we want to highlight is works out of the box for a wide range of tasks, right? And it's about learning what tasks to use it for and what not to. And we have to focus on training the users, right? Rather than only focus on training the models. Focusing on training the users is an equally important task. And if you're, and the other important thing that lots of people have been questioning is my data ready for AI, right? And what we want to highlight is the way we are using generative AI here, you can bring it any kind of data and it's understanding it, right? OpenAI, we have been amazed by its ability to understand the context, understand the data, and give you the right responses as well. And so the job is, I think, to set up the right AI organization structure and governance and not to wait here. And we are here to help. Soliton is a company that, we are now helping our current customers, and we are very happy to talk to those of you who are interested to see how to, implement something like this in your organization. So with that, I want to just play a short video that we have created that just goes through this in about 2 minutes. And with that, we will stop.
All right. Now, may I request Mr. Tukaram Tage to felicitate Dr. Ganesh Devraj.
Thank you all for staying back till the end of the day. We have more interesting sessions tomorrow, starting at 9 o'clock. Request all of you to be here before 9. We have, the team has put together excellent lineup of speakers, good topics. Unless you're present, that's of no value. So we want all of you to be there by 8:45. And I think till 5 evening, we are closing a little early tomorrow. Till 5, we have sessions continuing. So that continues with automotive, healthcare, and then we have sessions related to government-related policies. So very interesting topics. I think schedules are with you. So please, join us tomorrow early, and you can join us for dinner now. Dinner start. Thank you. Thank you. And I would like to thank the entire team and volunteers for coordinating and supporting throughout the day. And thank you very much, Ma. Thank you.